Hey everybody, we are here. Let some people trickle in as we get started. Welcome, welcome. Hope this is all right. No. There we go. Hope you slept better. I didn't. I have a dentist appointment. And it turns out I need a root canal. And it's not my fault. Ain't that just the pits? It's because I have weird tooth anatomy, so I have a root that's sticking up near the edge of my tooth. And the worst part is that my dentist isn't in network. Oh no. So not a great start to my morning, I'll tell you that much. How do engines work in space? Engines work in space in the same way that firearms would work in space. The idea is pretty straightforward. Oh, sorry, I have to turn off. One sec, I gotta turn off the members only. One sec. You can't push off anything? You don't need to push off something external. You can push off of something that you're shooting out. That's what rockets do. Okay, good. Firearms work in space and they have recoil. It's the same mechanism. Can we convert electromagnetic waves into magnetic energy and then vice versa? Sure. All you need to do is you could capture electromagnetic waves via radio antenna, for example. That's how radios work, and then you could use that to power an inductor, I guess, and that would store energy as a magnetic energy. Dental insurance is the biggest scam. It is. It really is. Rockets work in oxygen? No, rockets don't require oxygen to function. Rockets are momentum devices, so they just chuck stuff out the back and it pushes them forward. When will we see more of Mrs. Blitz for KSB streams? That's up to her. Can you explain how space might work past the matter field of the entire universe? As far as we can tell, there's no reason to think that there is space where there's not matter. Yes? Of course they liked you. Don't be silly. Can I travel in time? How much energy I need? You can travel forward in time. Traveling backwards in time seems to be very challenging. Can you explain how did the Earth get the magnetic field? That's actually an open question. There's something called the geodynamo effect, which is the source of the Earth's magnetic field, but it's not clear how it got started. What do you think of the current UFO activity and what theory you have for propulsion? I don't think that they're aliens, and I don't think that they're propelled in a particularly fancy way. I think that a lot of them are birds or plastic bags. What is the size comparison of a photon of light and a quark? So a photon of light has no minimum size, nor does a quark. They're both point particles, although photons of a certain wavelength do have a size because it's their wavelength. That's the relevant scale factor for that photon. Why do Nobel PhD holders look down on lowly masters? Why do Nobel PhD holders look down on lowly master's degree holders? I don't know if they do, but the PhD is just a higher degree, right? So you think spacetime is emergent rather than fundamental? I'm not sure. Can you explain how information dynamics might play into emergent spacetime? It's not clear that it does. When me smash two special rock together, they make pretty light. How? It depends on the rock and it depends on the kind of the light. But There's something called triboluminescence, which happens when basically like two things rub against each other really hard. They could produce light. I have a video on this, but essentially what's happening is that it seems like that there is a dislocation, like an atomic dislocation, that gives off energy when the bonds are broken, if I remember correctly. But go watch my video on it. I have a lot more detail. What's your opinion on the Tic Tac UAP? That it is unidentified. What do you think of the Boogosphere? I think that it was probably a hoax. How can I debate flat earthers that refute scientific claims? Make fun of them. Jail, the whole members only thing, I only do that for the last half of Ask a Physicist. So I do an hour and a half of open questions, and then I do an hour and a half of members only questions, just to incentivize people to support me. Oh, by the way, while I have you here, so I think I've been trying to implement this, it's hard to do, but if you are a super fan, which is like a paid member on TikTok, can you check in like on the live screen if there's some option for you to go click on a Discord link? Because yesterday I added an integration between TikTok superfans and Discord, and hopefully it would give you a Discord link and automatically assign you a role so that you can get access to some perks that are external to TikTok. If you have that superfan role, please let me know if it works. Please let me know if you can find anything like some sort of Discord link or something on the TikTok live stream. That would be really good because I have no idea how it works. I'm trying to make it work so that even TikTok superfans can get access to the debate notes. So please let me know. What really light up bulb and circuit, current, voltage, or energy? How does it delivered really? All three of them are involved, right? They're all involved. A voltage drives a current. The current carries energy. How do you find a very specific research topic for your senior thesis as an undergrad? Well, I think that the thing to do is to go talk to a professor and ask them for suggestions. Do you believe the Calabi-Yau manifold is fundamental? I mean, not necessarily. It's important, but I don't know if it's like a fundamental substance or something. Did the YouTube and Twitch chat break again? They shouldn't. They shouldn't be broken. How old am I? I'm 32. What do you specialize in? I specialize in gravitational physics broadly, but more of like the large scale stuff rather than the nitty gritty of like gravitational waves. And so like, I'm interested in like the global structure of black holes and like global topology and global geometry of the universe as a whole, those kinds of things. Do we see an electromagnetic wave out of the visible light is black? I don't know what that means. Do you think we'll ever be able to teleport via entangled particles? So quantum teleportation is a thing, but it's not like transferring matter from here to there. What it is it's taking a particle here and then destroying its state here and copying its state to another particle over there. If time slows down near a black hole, wouldn't time stop when you reach the surface? Relative to an external observer, it does appear that that's what happens, yes. But that's not what happens if you are actually falling past it. When is Atheist Debate again? I do that on Fridays and sometimes Thursdays, depending on whether or not we get bites for other topics on Thursdays. What do you do if you don't have the money or the right education to get a physics degree? Then you don't get a physics degree. What engineering major do you think is best to follow? I don't know, I'm not an engineer. How does the physicist make the majority of their money? It depends on where or how they're working. Can you explain how bosons and photons allow for subatomic particle interactions? So photons are a kind of boson. And what's really happening here is that the way that we describe the motion of particles is not just in the four-dimensional space-time, but also in a way, it's connected to kind of like an extra, or maybe I should say like an internal dimension that's located at every point in space-time, call it like an internal degree of freedom, that also has curvature in there. So in the same way that like The curvature of spacetime affects the motion of all particles. Charged particles experience an extra kind of amount of curvature from the fact that this internal degree of freedom, which we associate with gauge bosons, can be curved or not curved. From H.P. Lovecraft with the $10, very much appreciated. What is quantum spin and how was the numbers decided? Well, so quantum spin is angular momentum. So a thing spinning has angular momentum. Think of like a spinning top. It's going to have angular momentum. And it turns out that electrons, photons, protons, all sorts of subatomic particles have angular momentum. Now the issue is that we usually think of angular momentum arising from like a physical object spinning. So there's like the center of the object which isn't moving, and then there's the edge of the object that's going in a circle. But electrons, for example, aren't made of something smaller that's spinning. It's not composed of a whole bunch of stuff and then the stuff is spinning around a center. They have angular momentum even though they're not spinning in that sense. So this is just an intrinsic feature of the particle that they have angular momentum. We call it spin because it behaves like spin, like an object spinning would, even though it's not actually spinning. Now, how the numbers were decided? Well, you can just measure the angular momentum of an electron, say, and it comes out to be in units of the h bar over 2. So you have plus or minus h bar over 2. And so we say that h bar is a unit of angular momentum, and then I'm sorry. And so we say that an electron has spin of 1/2 because it comes in h bar times a half, right? It has half a unit of angular momentum. So that's how the numbers came about. Why isn't Mercury tidally locked to the sun? I think it's in a tidal resonance, right? Mercury tidal resonance. Yeah, so it's in a 3-2 spin orbit resonance. So it's not tidally locked because it found a different stable configuration, basically. They say mass attracts matter, but that is in emptiness of space. What about in this environment? It happens everywhere. How can something have angular momentum if it's not spinning? Angular momentum is an intrinsic part of a thing, right? It can be, at least. You can work out the math for these are so-called, let me back up. The way that we describe particles, the fundamental mathematical description of particles is in terms of something called a representation of a group in particular, or an algebra. And so those representations tell you kind of intrinsic features of that thing. So the representation can tell you about the mass. Different masses have different representations. Can tell you about the charge. Different charges, like if two things have different electric charge, then they occupy different representations. They can have different weak isospin. They can have different QCD color charge, and so the kind of representations, the kind of distinct representations that you get, depend on the symmetries of the system. So because our universe has this thing called a U1 symmetry, there are different representations for this U1 group. And those representations correspond to electric charge. Similarly, we can talk about momentum representations. If an object, because our universe has translation variance, meaning that the physics are the same here as they are over here, there is a representation that corresponds to how much momentum a thing has. So if two particles have different momentum, then they have different momentum, right? Or if two particles behave differently under this translation symmetry, then they have different momentum. Now, there's another symmetry of our universe, which is spin. Sorry, not spin, rotation. If you rotate the universe, the laws of physics look the same. And so that means that everything in our universe is going to occupy a representation of the spin, or of the spin part of the, in this case, it's the Poincare group. Or of the rotational part of the Poincare group. And that's the thing that's called spin. So when we talk about fundamental particles, which occupy these kind of irreducible representations, is what they're called. One of the components of the representation is the spin, because that is one of the kinds of symmetries that exists in our universe. So everything is going to have spin, everything is going to have charge, everything is going to have some amount of mass, everything is going to have some amount of momentum, everything is going to have everything takes on a value for one of these representations. It's just for some things it's 0, for other things it's not. In this case, for what we call fermions, they have the spin representation of a half. From Mika Makapo with the £5, Ooh, I have one, Dr. Mr. Blitz. Is nothing considered inherently unstable? I think we've never had nothing to find out, but could that be why? It's not really a physics question. Physics doesn't really know how to talk about nothing. Because physics is the study of matter and motion and fields and forces. And if you don't have those things, then it doesn't seem like there's anything to talk about. It doesn't seem like physics can talk about it. From Josh P with the $2, is space a fluid, or has that idea been proven wrong? Yeah, the idea that space is a fluid dates back to like the 1800s, but that's been kind of proven wrong since then, since the late 1800s. Hi Blitz, just had a physics exam and I expect like 60%. Am I cooked? Not necessarily. When I was an undergrad, taking my first quantum mechanics course, the average exam for the first midterm, the average exam score for the first midterm was 28%. So you might not be cooked. How can you measure the spin direction of a quark? It's angular momentum, and so angular momentum is conserved. And so you can look at the angular momentum of what comes out, because you can't look at the quarks themselves directly, but you can look at the angular momentum of what comes out, and then you can infer the spin of the quark. Do physicists use the term symmetry to describe intrinsic properties of a particle? Symmetry is more of a mathematical term, or rather it's a mathematical description of like a kind of transformation. So when we talk about, say, spherical symmetry, what that means, so there's a way to mathematically describe spherical symmetry, and it's if you take an object, or if you take the laws of physics, say, and you rotate all of your positions about some axis by some amount, then those laws of physics or that object remain unchanged. And what this is saying is that if you take like a physical thing, the laws of physics won't be different because it's rotated. Like the way that it behaves won't be different because it's rotated, except because of the fact that perhaps it's oriented differently. But the actual laws aren't different. The laws just might be responding to the different orientation. So symmetry is trying to describe a fundamental thing, with the exception of gauge symmetries. Gauge symmetries, on the other hand, so the global symmetries, like rotation is a global symmetry that I described. The gauge symmetries are not true symmetries. They're not physical symmetries. Rather, the gauge symmetries are kind of mathematical symmetries that have to be added in to remove redundancy of the mathematical description that we have. Why do we just get rid of the trace sector when deriving GR? You don't. There's a trace sector. I don't know how you're deriving GR, though. GR is not usually derivable. Do you mean like from an Einstein-Hamilton action? When an object approaches light speed, its mass increases, so does its gravity also increase? The mass of an object doesn't increase as it approaches light speed. What happens is that its momentum increases non-linearly, but the mass is defined as the energy that it contains when it's at rest divided by the speed of light squared. That's the mass. That's how you define the mass of a system. What's the lowest you ever got in a physics test? I don't know, probably a B+. They really needed a different grading scale for upper division courses. The first quantum mechanics course I took was not upper division. What do electrons actually look like out of atoms? I know about 2882, but I heard they were clouds, and are there electrons inside atoms? So electrons don't really look like anything, right? They're smaller than light, so you can't see them. What we can say is that the electrons occupy what's like a probability cloud, or you could even say that the electrons are the probability cloud around an atom. It's not something that you can see. It's more of a description of the way that the electron is. It's spread out kind of in a kind of diffuse manner around the nucleus of an atom. Is the toroidal shape of a magnetic field a sort of blown up image of electron spin? Not, well, okay, so you can have, so electrons and all fundamental particles are going to have a magnetic dipole moment, and a magnetic dipole is this kind of toroidal shape that you're familiar with. But that's not the shape of all magnetic fields, right? You're talking nonsense. Gauge has a mass gap exactly because of this mistake. No. So gauge theory is what a gauge theory is. It's a local symmetry, and local symmetries are not physical, right? When you write down the field equations for a like we can just talk about the U1 gauge symmetry, for example. When you write down the field equations, the Maxwell's field equations, what you find is that the the field only has 2 degrees of freedom, right? The electromagnetic field only, the propagating degrees of freedom for an electromagnetic field there's only 2 of them. And yet there are 4 components of the electromagnetic field vector. And so the gauge symmetry effectively reduces those 4 to 2 so that you're not overcounting things. That's what the gauge symmetry is for. Why do you need to fix those gauge modes? Can we not just keep it? Well, so there's only 2 physical gauge mode, or there's only 2 physical degrees of freedom for a photon, for example. But there are 4 independent components of the electromagnetic 4 potential, right? And so you need to provide some sort of constraint. It doesn't really matter what the constraints are, but you need to provide some sort of constraint that kind of fixes 2 of the components, because there's only 2 physical components. So like if you try to keep all 4, then you run into like failure of unitarity. Are you still researching conformal geometry? I am. Let's drink some water. Do photons have mass? They do not. What are your thoughts on the algebraic Haag-Kastler approach to quantum field theory? I'm not familiar with it, so probably complicated. Is that a pic of the back of my head? What? Is it possible that electrons can be broken into 1/3 and 2/3 charge components like protons? As far as we can tell, the answer is no. But I mean, maybe we just haven't smashed them together hard enough yet. Why do we need so many data centers? It's as good a question as it's a good question. I agree. Why do we need so many? How do magnets work? Magnets work fundamentally because electrons are tiny little magnets. And permanent magnets, like the kinds that like you can just make out of iron, basically line up those tiny little magnets to make big, strong magnets. Why do black hole solutions in d=3 tend to be are always locally ADS3? So the best explanation that I could offer here is that in 3 dimensions, you have no gravitational degrees of freedom, right? So all you're left with is topology. And so it just doesn't seem like that there's probably just not a lot of ways that it could be. And then you can probably work out the details as to why it has to have the curvature, the sign of the curvature that it has to get ADS3 rather than DS3. If spacetime is curved, does that mean space is curved? Is a mile longer in one direction? Well, a mile is always a mile, right? But the point is that the way that distances kind of the way that spatial distances kind of stitch together can give you curved things, right? So like, think of a sphere, or think of a Pringle. On a Pringle, the shortest distance is going to be like this way or this way, not really the other ways. And so the distances, if you travel like the same coordinate distance in one direction, it could take you further than in another direction, but you can still measure distances. The point is that the distances kind of stitch together in a way that produces the curved shape. What shape is the universe? As far as we can tell, it's flat and infinite. But it also could be flat and finite. That is just bigger than the observable universe. I don't understand how your derivations require 0 cosmological constant. Does the evidence indicate that there is a positive cosmological constant? Well, the evidence indicates that dark energy density is positive right now. The question is whether or not that thing is a cosmological constant, or whether or not it's arising from some, some fundamental field or something else entirely. And so the calculations that I did, they just suggest that there is an instability at the quantum gravity level if there is a cosmological constant. But keep in mind, the model that I was using was a very, very, very simplified model of the actual universe. It was 2-dimensional. It only consisted of 4 space-time points rather than infinitely many, and so on. Does radiometric dating rely on the weak nuclear force, and what would happen if the weak nuclear force was stronger? It does rely on the weak nuclear force depending on the kind of radiometric dating that you're using, and what would happen if the weak nuclear force was stronger? I guess you could. I guess it would affect the rate of radioactive decay. The thing is we have no evidence that the forces have been different strengths at different times. So, I mean, if you can provide evidence of that, you'll win a Nobel Prize, regardless of whether or not radiometric dating is different. How do we use the output of Schrodinger's equations? What do we do with the probabilities? Well, they tell us where things are, right? They can also tell us about like the energy levels. They can tell us about the amount of energy that it takes to go from energy A to energy B, which will tell us about how much what kinds of photons an atom can absorb, all sorts of things. Physically, what is a magnetic field? What is it made of? It's not made of anything. As far as we can tell, it's fundamental. Is there good job opportunities with a physics BA? If you want to go straight, if you don't want to get a like a PhD, with a physics BA, you're going to end up probably doing engineering work or software work or maybe finance. That's the reality of the world that we live in. Just admit that there is no good explanation. Protons are also like tiny magnets. No, electrons are literally tiny magnets. They have intrinsic magnetic fields. They're not made of something smaller. They are intrinsically magnetic. How does quantum entanglement work? Is it possible that it is controlled by a quanta or particle? Probably not, at least not locally. The best analogy for quantum, or you're asking how it works, not what it is. So how it works, this is not a known question. We don't really know the answer to it. My guess is just that there is here's my best guess, and this is speculation, but it's a fairly popular view. My guess is that at the fundamental level, there isn't space. There isn't time either. And what we think of as space is really just the kind of the local behavior that arises from quantum mixing. But sometimes, and so we kind of get this causal behavior where things only affect things that are nearby them. But sometimes you'll have some particular kind of quantum mixing that leads to entanglement. And so these two things act like they're right next to each other, even though they're not. Even though the location would be as if they are far apart. That's one way to think about this. Now, whether or not you're sold on that, I'm not sure if I'm sold on that, but that's an idea. What do you think is the correct interpretation of diffeomorphism invariance at the quantum level? I have no idea. Yeah, I have no idea. Really, really hard to say. Isn't that its geometry as opposed to shape? Well, that geometry and shape are very, very similar words. They're often used interchangeably. Just as a request for those of you who are members. So, by the way, let me just actually double check, because I think I can look at who's currently... Are there any super fans in chat right now? Like the people who are, who pay like $5 or $7, $5 a month or something. If you're a super fan and you're in chat on TikTok right now, this is only a TikTok thing, so I just have to ask this for some technical stuff. Can you see if you can look around on the live stream to see if there's like a place where you can join a Discord server and get an official, or get like an automatic role? Because I'm trying to integrate TikTok superfans into the Discord server so that you can get the same perks that the YouTube members get. But I don't know what it looks like on your end. So if you are a superfan, you can like look around and see if there's like a place where you can join a Discord server. That would be really good. And then let me know what happens. And if you want to become a superfan and you want to test this out, it's like $5 a month or something like that. I don't remember how much it was, because when I said it, it was in a different currency. From Joshua Brown with the $2, why can't you violate thermodynamics? You kind of can. It depends on which part of thermodynamics. But thermodynamics, the thermodynamics that comes from statistical mechanics, that's just statistics. So there's not really some underlying laws of physics. It's just statistics, right? So C-Bar, you said it works. So please click on the Discord thing and see if you actually get the role. That would be super, super excellent if you can. Aha, okay, well, wait a minute. I don't know how YouTube horizontal members are. I'm specifically asking about TikTok members. not YouTube members. TikTok members will get it too, but TikTok members already have access to all this stuff. So C-Bar, let me see if you have the role, because I don't see you having access to the members benefit chat. So it seems like you didn't get the role automatically. Brody, thank you for becoming a super fan. I appreciate that. So if you guys could dig around and see if you can get the Discord role from TikTok. I know YouTube will get it, no problem. That'd be super awesome. And let me know how it works, and because I'm not really sure how to make it happen. You get no benefits for being a super fan? Well, no, the point is I'm trying to integrate the super fan benefits. I'm trying to integrate the benefits that I normally get, that I normally give to YouTube members, YouTube paid members. I'm trying to integrate them to Discord so that I can get them the debate notes that they would otherwise get for being a member on YouTube. So that's the goal here. Because I know that some people don't like YouTube, they prefer TikTok. And so I don't want to just deprive them of the benefits there. But thank you guys for checking that out. And, you know, I'll touch base again another half an hour and see if it's working. From AS or from ATS LLF with the $5, can you explain how light slows down despite not having mass? So when light is passing through a medium, it's not really light anymore. Light, the way that we kind of describe light at a quantum level is that it is a photon traveling freely through a vacuum. Once it enters a medium, you now have the electromagnetic field interacting with electrons typically, or the lattice perhaps more specifically. And so they kind of interact and propagate together. But it's not a photon anymore. A photon is a thing that travels through a vacuum freely. It's interacting, so it's not freely traveling anymore. What are the consensus? Did the laws of physics exist before the Big Bang, or was created when it happened? So the laws of physics, I don't know, this is more of a philosophy question than a physics question. My view is that the laws of physics are not things that exist. They are mere descriptions that we came up with to describe the way the universe is. Are you letting guests up? I will in about an hour. Can you explain annihilation reaction studying PET scans? So all that happens is that you have a piece of matter and a piece of antimatter that are the exact same. There is a kind of overlap. There's a kind of interaction that they can do where they both cease to exist and they instead become a pair of photons. And the reason why this is possible is because matter and antimatter have the exact same charges but opposite each other. And so one of the ways that you can figure out which kind of interactions are allowed is by looking at, or the kinds of interactions that can happen are any kind of interaction that basically preserves all of the conserved quantities. So if if the only non-zero conserved quantity that happens in an interaction is the charge, then all of the possible outcomes are allowed so long as they conserve that charge. So in the case of matter and antimatter, all of their charges cancel out. So the total charge of the system when you have a matter and antimatter particle is zero for all of the different kinds of charges. And so what that means is that the output of that kind of interaction can be something with zero charge, which is in this case just gamma rays, a pair of gamma rays. So that's a thing that can happen. Oh God, my teeth. They poke around with the scalars and makes your whole mouth hurt. And I need a root canal and a crown, and my insurance doesn't cover much of it, so that's going to be fun. Why are photons not quasi-particles below the ground state? Well, there is no below the ground state. Why only the photon is the only boson streaming freely? So the W and Z bosons, they don't propagate freely. Well, they can propagate freely, just not for very long because they're heavy. They have mass, so they decay. Gluons have charge, so they cannot be isolated because of confinement. At least that's the idea. The Higgs boson can propagate freely, but again, it's heavy, so it'll decay. Can you give an intuitive explanation of what happens physically that makes this necessary? Oh. Okay, hold on. So sorry, I feel like I missed the question. From Az Utkarsh with the 100 Indian rupees. I know calculus, but don't know how to use them for making my own equations and for research papers. Undergraduate student. Any quick guide and book? There isn't a quick guide to doing research. What you'll need to do is find a professor that was willing to work with you and have them mentor you, because research is a learned skill, but it's not learned out of a book. I don't know if that helps. Can you build and send a rocket to the Mun? Blitz, you can build and send a rocket to the Mun, but you can't do your own dental. No, I can't do my own dental. There's a paper called The Physical Origin of Torque that explains this assuming a non-rigid body, and the explanation relies on the forces of the particles that make up the lever arm. Yeah, what about it? The laws of physics as defined were invented by humans, but how matter and other things in the universe interact with each other over time has been around. Yeah, so the ways that they interact with each other, that's been around since they've been around. Do you know about the work Young and Pauli did together? I don't. What do you think of the scientists who are either missing or dead? Well, there's only a few of them over the last 5 years, and scientists die sometimes. Scientists even sometimes go missing, and it doesn't have to be mysterious. Where can I learn independent without going to college uni? I mean, there are some resources like MIT OpenCourseWare, Khan Academy, some YouTube channels have like course lectures, but it's going to be, it's not the most efficient way to learn. It's the reality of it. Are Tesla coils real? Yeah, you can build one. They're just not magic. How do we measure the rotation speed of galaxies to know they're off? Is it through the Doppler shift? Yes, it's precisely through the Doppler shift. Okay, so it looks like that the Discord link from TikTok is still not working because I don't see anybody in the Discord server that has the right... Actually, let me double check something. Let me double check if anybody has that role yet. Roles. Yeah, so nobody has the superfan role yet, so I guess the Discord link isn't automatically giving you a role, which is kind of annoying. If you are already in the Discord and you can, prove that you're a superfan, I want to say file a ticket on the Discord, submit a ticket of some kind, and just like with a screenshot that shows that you're a superfan, and then we'll give you the role manually. Just that way then you can get access to that stuff. Was Einstein wrong about anything, or was he just limited by the technology of his time? I mean, he did make an incorrect prediction in his special relativity paper, and he never corrected it after he came up with general relativity. But was he wrong? Did he say something was... I mean, yeah, if you make a wrong prediction, then yeah, you're wrong. Did you recently mention Dirac's proof that if magnetic monopoles exist, charge has to come chunked? I did, yeah, and I have a video on it, actually. Can a physics professor hold the position of head of engineering department? Well, I imagine if they're head of the engineering department, then they're probably a professor in the engineering department, which would mean that they're an engineering professor. Our photons are no longer photons affected by environmentally assisted quantum... I don't know what that question means. From Joshua Brown with the $2. How much would it cost to hire you to tutor calc? A lot. Just because I already am super, super busy. So I'd have to give up doing something that I'm already working on, that I already spend time on. So I'm not... it'd have to be excessive to make a special exception to make me want to do this. Could I already have a chosen role? So yeah, we'll need to see C-bar. But it doesn't look like I think you can have multiple roles, and so I'll need to give you the role manually, which is fine. We can do that. You said before you're of Jewish faith. Why is that? I'm not of Jewish faith. I'm a Jewish person. Guess who's probably going to Glasgow for a conference? You're going to Glasgow? What conference? I want to go. I've never been to Glasgow. Still plan to give that access to Twitch subscribers? Yes, the plan is to give everybody the same access. The trouble is right now Twitch is being buggy, so it's not giving me Twitch affiliate, even though I meet all the criteria. So I sent in a support ticket yesterday. Hopefully they'll get back to me and they'll give me Twitch affiliate, and then I can integrate Discord into Twitch as well. So yes, I promise all of these things, we're trying to get everything kind of unified so that everybody has access to the same stuff, but it's just taking some time. You can buy a round trip to Mexico and get a root canal and crown for under $2,000. I'm familiar with that. My concern is that I would only want to go to a dentist that the dentist that I typically go to is familiar with and does good work. I'm already nervous about the dentist. EIC user group meeting. Okay, I guess I can't go. Can you invite me as like a special speaker? Like to talk about how we should communicate science or something? I'd like to go. We know mass exert force, correct? How could that happen? Mass doesn't really exert force. It changes the structure of spacetime, or the shape of spacetime, if you will. Can you explain the term event horizon to an idiot like me? Well, I'm sure that you're not an idiot, but I'm happy to explain. The idea is fairly straightforward. Okay, fairly straightforward. The idea is merely the event horizon encloses a region within which no outside observer will ever be able to see anything that happens from the inside. That's kind of just the definition of an event horizon. No signal from you just define a surface in space as the boundary between a region inside and a region outside, such that the region inside can never talk to the region outside. When modeling things mathematically, it seems to become some clunky system of PDEs all the time, and it's very annoying. What is your approach when this happens? Well, you can either look for symmetries or for ways to simplify it, or you just chuck it at a computer and hope that it can numerically solve it. What are some of the things we can do with the 48 topological photons that was discovered? I don't think that that's true. I don't know what you mean by 48 topological photons discovered. Oh, you're talking about 48 dimensional entangled light. Okay, so this is not actually 48 dimensional. It just has 48 degrees of freedom. Why are white objects so bright when I hold them in sunlight, but not other colored objects? Well, white objects reflect all of the light. So if it's reflecting all of the light, then it's going to be bright in the sun. What do you think are the job perspectives in the future for math and physics, good or worse? I have no idea. Is entropy a thing or just our lack of understanding? Entropy is like a way of kind of quantifying our lack of detailed knowledge. Do you think naked singularities will be found, or are they simply mathematical? They might be simply mathematical, I don't know. Is it true that James Webb shows evidence we may be living in a black hole? No, not really. There are many videos with different scientists who said in interviews, if I come up missing, you know why, like Amy Eskridge. Amy Eskridge wasn't a scientist, nor was she working on anti-gravity. Also, there are not many videos of this, actually. But people do say that kind of thing a lot when they're paranoid. If it's just a root canal, you only need a good dentist. Well, I mean, like, yeah. Well, you need an endodontist, apparently. My glasses are crooked? Maybe your eyes are crooked. Have you ever thought of that? I like the black hole universe hypothesis. It's fun to think about. I mean, if it's fun to think about, I guess. I just don't know. I just don't think it's true. I don't think that we have really good reason to think it's true. Yeah, if you become a channel member, you can call in when the stream switches to members only in 45 minutes. I'm still trying to work out how to do that, because currently I think anybody on TikTok can join. I don't know how. I don't know how to make it so that only TikTok members can join, but I am going to make it, once the Discord thing is up and running, I'm going to just filter everybody through to Discord, and then you'll need to have the YouTube membership or the TikTok membership or the Twitch membership to then join the channel so that you can. I am going to do that, but for now I think it's just anybody is joining. What would our universe being in a black hole even mean or look like? Well, what it would look like is it depends on what the inside of a black hole looks like. It might look like just, like we might not even be able to tell. What it would mean is that somehow there's like nothing, there's like empty space outside of our universe, which would be very surprising. Since the Higgs field only gives mass to elementary particles, but 99% of a proton's mass comes from the binding energy of a strong force, is mass fundamentally just confined energy? Yeah, mass is the energy of a system at rest. It's a setting before you start the live. Well, that I know, but I don't know how to make it so that only subscriber or only super fans can become guests. It's not that I'm afraid. It's just going to be expensive and it's going to suck. Like I've had painful stuff before. It's just expensive and it's going to suck. And I hate paying money, a lot of money, for procedures that hurt and are unpleasant. Is there an estimated size of the universe beyond the observable universe? There's an estimated minimum size. The minimum size is about 300 times the size of the observable universe. That's about the smallest it could be. I reached out to you for a potential collaboration regarding a paper, but didn't hear back at all. Should I just resend it? So generally, the only people I'm looking to collaborate with are other scientists in the field. If you're a mathematician and you want to and if you're a mathematician who does differential geometry and you want to do some conformal geometry with me, I will probably reply. If you are a physicist who does cosmology or black hole physics or gravitational physics in some way, and you want to work on something because you're interested in what I've worked on, or you have an idea that you want to run by me, I will probably reply. But if you're not one of those things, I probably won't reply, because collaborations are not, I'm not just collaborating with just anybody out here. I'm looking to collaborate with other people who will contribute meaningfully to the same research project. Is AI impacting your job? Not really, because the way that I make most of my money is by making educational content. From 00 01 Devo with the $15, very much appreciated. Please tell Mrs. Blitz I'd love to see more of her. She was great during the KSP stream. Use this to treat her to a coffee or treat. Sorry, I'm getting her attention so that she can read the super chat.
What did I do?
You didn't do anything. Just read this.
Please tell Mrs. Blitz I'd love to see more of her. She was great during the KSP stream. Aw, thank you so much.
See, I told you people like you.
Aw, you're so kind.
This is how we encourage her to be on live streams more, y'all. Do you think the Big Crunch is a decent prediction of the end of the universe? It's a possibility, but at the moment, we don't really have any data that says that that'll happen, because we don't really have any data that suggests that singularities even exist. What do you think about the Hyperloop? It's probably been way too expensive. What current research are you most excited about? Well, currently I'm working on a project that involves like kind of a stochastic cyclic model. But I reached out to a professor who's very famous, not because he's famous, but because he wrote a paper that's my paper would kind of be a follow-up for, and I'm waiting to hear back from him. Although I've heard that I probably won't hear back from him, which is kind of annoying. Because I would like to collaborate with him, because it'd be a good follow-up for the paper that he wrote 6 years ago, but maybe not. Where did you get your PhD? Thanks for your work towards scientific progress. I did it at UC Davis. We should have trains. We should have trains. If singularities don't exist, then what was the Big Bang? It was, in my view, a very small, hot, dense state that expanded for reasons that are yet to be determined. Aren't singularities just mathematical errors in classical physics where you have to divide by zero? Yeah, basically. Stochastic and periodic as in time crystals? No, not really. Stochastic and periodic as in it's finite, so it will inevitably trace out all possible configurations, and so will eventually come back to where it started. But the amount of time that it'll take to do that is not predictable. What does your job look like? Well, so when I'm not creating content, producing science content, doing debates, editing, things like that, for the 5 hours a day I spend on research stuff, it's a decent chunk of reading, a decent chunk of calculating, a decent chunk of writing. When the universe was a hot dense state, what were all the things it contained? Well, it just contained excited fields, is the idea. Can you recommend a route to publish a paper which may resolve the Hubble constant? Submit it to a journal. A good journal is Classical and Quantum Gravity. It's a pretty popular journal. I've published in it a lot. It's a pretty good journal. You can also, if you think you're genuinely solving the cosmological constant problem, though, submit it to Physical Review Letters. It's probably the best journal in the field. Are you ever in a lab? Nope, I'm a theorist. What kind of hobbies do you have? Video games, Magic the Gathering lately. Let me hydrate a little bit. Has your theory that you've been working on for the last 2 years taken off? I don't know which one you're talking about. I published a paper last summer that is finally making its way to print. That only took a few, like a month or two to actually write the paper. Although I was thinking about it for a while. This new idea that I'm thinking of is a little bit more sophisticated, and it's hard to get right. So, you know, this one is still in the works. This one that I was talking about that is related to this kind of famous professor guy. I'm actually just fidgeting with a Magic the Gathering deck box right now, although you can't see it because of the green screen, but this is a Magic the Gathering deck box. Can non-degreed citizens submit research papers? Anybody can submit research papers, but if you don't have a degree, almost certainly they're not going to be useful or meaningful. Which decks are you running? I have a lot, but this is my favorite. Signed and altered by the artist. Unfortunately, his signature looks like that of a kindergartner, but he's a really talented artist, so, you know. I didn't ask for the signature, I asked for the alter, and then he signed it anyway. Is my nose healing? Not quickly, and it's going to leave a nasty scar, so. Yeah, I agree. Hasbro has been off the rails with the print frequency. I liked it when there were 3 sets a year. That was good. Do you believe we already have anti-gravity and possibly time travel into the future at the very least? No, not at all. I don't think that we have that at all. Do you make your money from TikTok debates and content, or mainly from your research? So, the majority of my income, and I'm super happy to be super open about my income. So something like 65% of my income comes from, maybe a little bit less, comes from making TikTok shorts. TikTok has a really good program where for a lot of different niche creators, but especially for educational creators, if your videos are sufficiently educational, sufficiently well-resourced, sufficiently well-produced, etc., you can get a big multiplier on the normal income that TikTok would give you for your content. And so that's the majority of my income. So like, depending on the video, I can make anywhere from like $1 to $3 per 1,000 views. And then per 1,000 qualified views, which is annoying, but it's a thing. And then if I get into this higher quality tier, then that gets multiplied by 4. So that's like a good source of income for me. And then about a third of my income comes from super chats from you guys, whenever I do Ask a Physicist or debate stuff. And then depending on the time, something like 5 to 10% of my income is for directly funding my research. But if you want to directly fund my research, there are ways to do it. If you go to Patreon, there's a Patreon tier, which is agnostic about my science communication, my debate stuff. It's just about the research, and you'll get like quarterly meetings, and you'll get acknowledgments in my papers if you join that Patreon tier, but it is very expensive. It's like, imagine that you're being a fancy medieval era patron giving money to a scientist, right? Where are you a professor? I don't work at a university. Have you had any experience in condensed matter research? No, I haven't. What costs aside from salary does your research have? Mostly it's traveling for conferences. So I just booked a 6-night stay in Pennsylvania for a hotel for a conference that I'm attending in July, and then obviously there's the flight and the food costs and things associated with that. That's the biggest expense for my research, or for my my research program, is just attending conferences and traveling to work with colleagues. In 4 dimensions, every Einstein metric is automatically Bach flat, but not every Bach flat metric is an Einstein metric. Any examples? Yes! Go read a paper of mine. I wrote it with Rod Gover. we talk about this explicitly. We talk about cases where you can build Einstein where you can build Bach-flat manifolds that are not Einstein pretty explicitly. All you have to do is take a compact Einstein manifold without boundaries, of course. So closed Einstein manifold, and then put a hypersurface down the middle. So the interior of the manifold will be flat, Bach-flat, because it's Einstein. Then now divide it in half with a hypersurface, and make that hypersurface have a non-vanishing trace-free second fundamental form. If you do that, then then you can treat the one side of that closed manifold, that closed conformal manifold, as a conformally compact manifold with a boundary, with a conformal boundary being this non-umbilic hypersurface. The conformally compact manifold has an associated Pfefferman-Graham metric. It's a conformally compact metric, which will be Bach-flat, but will not be Einstein. So that's one way to build them. And we actually just got referee reports back on that paper, so I have to look at that probably later this week. Oops. How come you chose to do TikTok instead of physics-related jobs since you have a PhD? So I did a postdoc in Europe for 2.5 years. Postdocs are hard to come by, and so I could have kept applying for postdocs, and I was offered one in New Zealand, but my wife wanted to move back into the US, and my wife didn't.
For 9 months.
It was for 9 months, but you know, it is what it is. And then it was for family reasons. I had good reason to want to stay put and stop moving around, especially to places where I don't know anybody. And I make enough money doing this, and so I can continue doing my research. I can still do outreach. So, you know, it was the right decision for me. How similar is a Comic-Con to a physics conference? Is there swag? No, there's not usually swag. What state am I in? I'm in Arizona. Who made the rules of the physical world, like gravity or electromagnetism? I don't think that was a person. I think that it's just the way the universe is. Ever debate a flat earth person? Every week on Monday. Is our universe, if our universe is in a black hole, an expansion to us Hawking radiation leaking to a parent universe? I don't think our universe is in a black hole, no. What books would you recommend for a layman to become more familiar with higher level physics topics? Read A Brief History of Time by Stephen Hawking. It's quite good. It's a little bit out of date, but it's quite good. How do you conduct your research? It really depends on the topic. So there's a project I'm working on right now where I'm trying to compute a specific quantity called a Willmore energy or a Willmore invariant for a 2-dimensional surface in a 5-dimensional manifold. In this case, I use a piece of software called Form, which is really useful for tensor manipulations. And so I can show you what the code looks like. It's sort of code, but it's not really code that I use to do these calculations. So here's what that looks like. It's just this, which is just calculations. It's not really a program. It's just calculations. Some of this stuff is commented out because I was testing something when I was working on it yesterday. And then the output looks something like this. Where is it? Oh, why can't I show you Bash? Okay, so I can't show you what the output looks like because I guess OBS doesn't like me showing you a Bash prompt, but that's kind of annoying. The output just... Oh, wait, no, there it is. Yeah, here we go. This is what the output looks like. And then I look through this and I see what other calculations I need to do, and then I go edit the file and then I rerun it. So that's what I was working on the other day. I thought you were in the Czech Republic. I was up until I moved. You're not employed at a university anymore? No. You ever been to Iowa? No. You watched The Boys? I haven't seen the newest season. Do you know Dr. Sheldon Cooper? You realize that Sheldon Cooper is fiction, right? If I want to get into learning physics, where should I start? You should start with classical mechanics. These are like Newton's laws. You can pick up a textbook or go to Khan Academy or go to MIT OpenCourseWare, and you'll find plenty of stuff for intro physics courses. If Hawking's book too elementary, do you recommend Sean Carroll's Biggest Ideas series? I do recommend that. If gold formed in star explosions, how did it travel all the way to Earth? Well, so it forms in neutron star collisions, actually. And then it spreads out everywhere. And it kind of just litters the universe. Some of it ends up in the gas cloud that eventually formed the solar system, and then some of it formed on Earth. Why is the mass of the sun used as the average mass for all main sequence stars in the universe? Well, I'm not sure if it's used as that. More so, it is that. But I actually don't know what the average mass of the stars in the universe is. So the average mass of a star in the universe is about it's apparently like 0.2 to 0.4 times the mass of the sun. So it's not used as the average size. Because it's not. Yeah, I'm using Sigwin because I'm averse to change. What is the great attractor? My guess is it's probably just a bunch of galaxies. What do you do in Bash? Is that a shell script? It's just Sigwin. And it's just running some software. The software is called Form. What is a breathing universe? Go read my paper about it. Blitz, did you debate a guy with a formula who claimed the population size proves a 6,000-year-old Earth? Yeah, I've debated a lot of people who've made that claim. Could a physicist be a great president? I think that there have been 2 heads of states that have been physicists, or maybe 1. I think Angela Merkel was a nuclear physicist. Or Angela Merkel. I don't know how to say her name. How does the Janabekov effect work? Go watch my video on it. It's on TikTok. You should be able to find it pretty easily. Just look up Janabekov and then Blitz PhD and you'll find it. But essentially it's a result of an instability in the, I want to say like the configuration space that happens because the moment of inertia tensor has 3 different eigenvalues. How big is the black hole in the middle of the galaxy? How long does the sun take to revolve around it? Well, so I think it's like a few 100 million solar masses, right? What's the mass of Sag A star? It is 4. Okay, so it's just 4 million solar masses, and it takes the sun like 200-ish million years to go around the Milky Way. How many papers have you released? Well, all of the papers that I've written are online available for free, and they're also listed on my website. It's like 17 or something. I don't know. I'd have to go through and count. After the first few, you kind of stop counting. Just because, oh, it's not your first paper anymore. It's not your second paper anymore. It's just like, oh, there's another one, right? Sorry, I'm just checking out something. There we go. Okay. Oh, let me check on the, why is my phone being so slow? Let me check to see if the thing is working. So we still have none of the people who are YouTube super fans. None of them have joined the Discord yet through the link. So if you are a TikTok super fan and you're not already a Discord member, try finding the Discord link on the live stream, and you should get access to a automatic role that's like a special role for TikTok superfans specifically. It is superfans specifically. Anybody can join the Discord server. It's discord.gg/drblitz. But the superfans get a special role, which will give them access to like specific perks that I'm trying to work out. I haven't sorted it yet, but once it's sorted, hopefully superfans will get access to those perks so they're not left out from stuff that the TikTok members get. So yeah, I'm trying to get that worked out because I want everybody to have access to the same stuff if they're all equally, doing that. What connects empty space? It can't be empty if light particles can make it through. Boots Void. Light particles don't need to travel through stuff in order to travel. In fact, kind of by definition, if it's traveling through stuff, it's not a light particle anymore. It's not a photon. Empty space is empty, and then stuff travels through it. How does light travel in space? By propagating along the electromagnetic field. Why are you not interested in climate science? I am. Do I need to accept the role? You shouldn't need to. It should just assign it to you automatically. What was your PhD dissertation on? It was on conformal hypersurface geometry. From Morgan Bratch with the 2 pounds, can modified GR explain away dark matter, dark energy? The best versions of modified depends on how you modify it. There's modified Newtonian dynamics, but the best versions of modified Newtonian dynamics still include some amount of dark matter, and they don't really try to account for dark energy. Some versions of modified GR can account for dark energy. There was something called cotton gravity, which was proposed a few years ago that claimed to account for dark energy, and I don't remember if they claimed to account for dark matter. But yeah, there are some things that are attempted to be accounted for via modifying GR and modifying Newtonian dynamics, but they're not well supported right now. How do tensor spaces come up in physics research? I know tensors do, but I'm wondering what the actual spaces themselves do, if anything, in the research process. They don't really, aside from like telling us what the irreducible components of a certain like tensor structure is. Otherwise they don't really. Would you say physics points towards the universe having a beginning or not? What's your opinion? In my opinion, it doesn't point, we don't have data that points either way. Is the universe random or deterministic? I take the view that it's deterministic on kind of a broad scale, but from a single universe perspective, it looks it's indistinguishable from random. Where'd you get my PhD? I did it at UC Davis. What is time? Good question. Might be emergent. Are you religious or resonate with any specific philosophies? I'm not religious, no. If you have an issue with Nightbot, please file a a ticket on Discord so that I can look over it, because I don't want you guys to have a bad experience with Nightbot. Have you watched the new Dr. Stone episodes? If there's new ones that came out more recently than 2 or 3 weeks ago, I haven't seen them. Earth's weather is created through air pressure in the sun, but what about planets far like Neptune? They're also going to have weather that's caused by a similar thing, but they also might have internal energy sources. Like they might be hot on the inside, and that could provide some energy as well. No, protons by definition, and the EM needs something to travel through. No, that's not true. The EM field exists everywhere. Photons travel through photons travel as excitations of the electromagnetic field. Why does quantum mechanics seem so counterintuitive compared to our everyday experience? Because we're used to things being one way and being predictably that way. Quantum mechanics is not that way, but the reason why the real world is not that way is because once you have a quantum system and you make it larger and larger, those kind of different ways that the quantum system can be kind of start averaging out and smearing out, and you're left with just one outcome. Have you ever been recognized in public now that you stream? I've been recognized from my videos. I think I've been recognized once from streaming, but my videos get a lot more traction than my streams do. The TikTok shorts, YouTube shorts, those kinds of things. Could you ever see a mathematical theory of consciousness developing eventually? Maybe. I don't know. It's not my area. You went to UC Davis. How was the silo? I ate at Shaw's every day for lunch while I was a grad student there, almost every day. And did I go to picnic day? I did once, but I wasn't big on it. Wouldn't debates on climate change be more interesting than flat Earth? Whether or not they're more interesting, I don't know. I used to do debates on climate change, and I still sometimes do. Can all the missing antimatter be beyond the observable universe? It could be, but that would be really weird. Why is it there? Do we all share an electron? No, I don't think so. We all have electrons, and electrons are excitations of the underlying electron field. Definition of empty space doesn't exist. What is there? Look, so when we talk about a vacuum doesn't have no properties. A vacuum has a vacuum has an electromagnetic field. It has a weak it has a Higgs field. It has a gluon field. It has all these fields. It's just it doesn't have any particles in it. And photons can travel through those, no problem. How soon will the New Horizons probe surpass the distance of the Voyager probes? I don't know. I don't know how fast either one are going off the top of my head. What's up with the Physics 7 series at Davis? It's intended for medical students or for pre-med students to get what they need for medical school. Could you explain how some infinities are bigger than others? So when we talk about two different sets being different sizes, what we mean is that you can't map from one to the other and vice versa without having multiple things mapped to one thing. This is called a bijection. A bijection means that two sets have the same size. So for example, the set of all even numbers is the same size infinity as the set of all integers, because for every even number you can map an integer, you just divide it by 2. And so there's a one-to-one correspondence there. But there's no way to map the set of all integers to the set of all decimals. There's in some sense more decimals than there are integers, even though there's an infinite number of integers. Do physicists get paid more than engineers? God, no. Sorry about that. I'll be right back. I'm just gonna go wipe my face. One sec. Sorry, had to wipe my face, wash my hands, you know. Didn't mean to sneeze, but I did. All right, let's keep reading questions. Do you think climate change will be solved using engineering and science? I would hope so. What are your credentials? I have 2 bachelor's degrees, one in mathematics, one in physics. I have a master's in physics and a PhD in physics. Are fractals an example of conformal geometry? Not quite. That's more scale invariance. Conformal geometry is related to scale invariance, though. From Goat with the 25 RON. I don't know what 25 RON is. Romanian Lou. That's the first time I've ever gotten a Romanian donation. Thank you. Blitz, can you explain the idea of fuzzy black holes? So fuzzy black holes are just this idea that the event horizon is not like some hard boundary, and rather that there's kind of like at least this is the idea. It depends on which version of fuzzy black holes. There are some stringy versions of black holes that you have like string stuff going on at this boundary. And so they're more like kind of like an object that is a fuzzy boundary in that way. There's also this idea that you can kind of have a, what are they called? Gravistar, which is also kind of a fuzzy black hole idea. Which doesn't genuinely have an event horizon, but there's some quantum stuff happening near where the event horizon would be. That's the idea, because there is this problem in, quantum gravity research. This problem called the black hole information paradox, where, on the one hand, we would think that once energy goes into a black hole, or once information goes into a black hole, you can't get it back out. It would be scrambled beyond recognition. And on the other hand, we have this idea that somehow in quantum mechanics, information is supposed to be conserved. And so fuzzy black holes are one way that people attempt to solve this. From Exploding Tiger with the $2, what inspired you to get into your field? So I've always been interested in black holes and cosmology, but I got into the specific area of like conformal geometry and the kind of physics that I do, because that was what my PhD professor was working on, and he seemed like a cool guy, and I just wanted to work with him, so I worked on whatever he was working on. What's your take on all the missing scientists and physicists and the ones that are dead? Well, as far as I know, there's only like 2 missing physicists and I think 4 total missing scientists over the course of 5 years, which is not really that much. Missing or dead, I should say. So I think that this is all just like, I think people are making a mountain out of a molehill. Do you believe that quantization of gravity is going to happen within our lifetime? Well, I don't know how old you are. Maybe. Can you speak on the shit Amy Eskridge was talking about? I can't, but I wouldn't take anything seriously that she was saying. She showed no evidence of actually being well informed on any of the anti-gravity stuff or quantum gravity stuff that she was allegedly talking about. It's actually 10 missing scientists? No, I've gone through and looked at all of the alleged missing scientists, and only like 4 of them were actually scientists. The rest were like engineers or administrators or secretaries. Do you think it's possible to develop and build a warp drive using materials found or synthesizable on Earth? No. No. 4 scientists over 5 years must be pretty average. Yeah. Is it possible that what we call a singularity could possibly be a gigantic exploding star, or is that size physically impossible? So it wouldn't be a gigantic exploding star. A singularity, well, it depends on what kind of singularity we're talking about. But certainly, no, the Big Bang wasn't an exploding star. It doesn't have any of the properties similar to that. If you ever go missing, I'll probably tweak out. If I ever go missing, I probably just got lost. What have you built or made from being a physicist? So I'm not an experimentalist, so I don't usually build experiments and things like that. My job is, so I publish papers, I write mathematical proofs, I produce new cosmological models, I study the asymptotics of black holes, these kinds of things. So that's the kind of research I do. However, in my youth, when I was a teenager and in my early 20s, I spent time designing lasers and circuitry to safely and effectively drive those lasers. So, do you like Weinstein's geometric unity? No. Sorry, I should probably jump down to the bottom because I'm a bit behind. Hey, your nose is healed? No, it's not. Still not healed. Can you explain how the singularities in complex analysis led to the mathematical description of black hole singularities? They didn't. These are kind of unrelated. They're both singularities in that they both have something diverging. In the case of a black hole, it's some sort of curvature quantity that diverges. In the case of a complex analysis, it's just some function that diverges, but they're not the same, or they're not really related to each other. What is up actually? What is down? Up is away from the Earth, down is towards the Earth. Is the best answer to the Fermi paradox that space is really big? Yes. Who's the most famous physicist you've met IRL? Who would you like to meet that you haven't yet, and why? Let me show you. One sec, I gotta pull something up. I have to go look at my albums, and then I have to go look at, here we go. Let me show you. So that's me with Roger Penrose. Definitely the most famous physicist I've ever met in real life. He was kind of pissed that I asked him to do a selfie with me, but look, he's in his 90s. I don't know how much longer I'm going to have that opportunity. So, yeah, that's the most famous one. I met him at a conference that we happened to both be at. Since we have the technology, should we resurrect Einstein using cloning? No, I don't think so. He does believe kooky stuff about quantum microtubules. That is true. Which would be harder, closing a black hole or moving faster than light? Closing... I don't know what you mean by closing a black hole. You can't move faster than light. Black holes do eventually evaporate. Grimlock just sent $10 for hydration donation, which is much appreciated. Why was he mad? I think that he just didn't want to be fanboyed over. Which, you know, I get. I totally get that. But you win a Nobel Prize, that's going to happen to you. I'm sorry. Even if you're old. How did the Kerbal submarine go? Still in progress. If black holes are so big, why aren't they consuming galaxies en masse? Well, not all black holes are so big. Some black holes are just a few times heavier than the sun. Some black holes are really big. But black holes aren't like vacuum cleaners. They're just things with lots of gravity. What would happen if the supermassive black hole at the center of our galaxy were suddenly ejected outward, and how could astronomers detect it? Well, it depends on how active the supermassive black hole is. Probably not much would happen because it doesn't make up a significant chunk of the mass of the galaxy. But we would definitely notice it, like the gravitational effect that it would have on things, like stars would be dragged along. Has the moon changed in the sky, or is that just BS? Yes, it's BS. Opinion on string theory, I heard that it was dropped by a lot of researchers. It's still probably the most popular quantum gravity model we have. In physics, what determines the system's identity through change? It's not. That's kind of a philosophy question, not really a physics question. Have any black holes evaporated yet? If they have, then we haven't seen them. Do you have any images of a black hole evaporating? Nope. It's very, very slow. Do Kerbal props even work underwater? No, you have to build your own. Have you considered changing your name to Blitz? My name already is Blitz. Barry Barish brought his prize to class and did a selfie with each student. That's fair. Do we live in a three-dimensional reality, or we actually live in a mixed reality? We live in a reality with 3 dimensions of space, 1 dimension of time. Do you believe in the CTMU self-simulation? No. Nobody does. No scientists do, as far as I can tell. Do you like studying elementary particles or the larger aspects of the universe? The latter. I'm more of a large-scale cosmology kind of guy rather than a small-scale particle physics kind of guy. Aren't they like big vacuum cleaners, though? The gravity is so strong it just sucks everything in. No. Things can orbit regardless of how massive something is, right? What happens if 2 black holes interact? They merge. They become one. Is it rare for our moon to face at Earth all the time and have an almost perfect orbit? No, not really. Circularization of orbits kind of happen just kind of on their own because it's the most symmetric way to have it, and tidal locking is also fairly common for moons. Is your first name Sam? It is, yeah. What were your grades in school? I got a 4.0 throughout school, and then in grad school I had a 3.97, I think, in undergrad. Or maybe I had a 4.0, I don't remember. And then I got I think I got a 3.97 in grad school. If invariant mass exists, how come I keep gaining mass when I eat two cheeseburgers? Oh, that's a you problem. What's the weirdest thing we've discovered thanks to an Einstein ring? Thanks to an Einstein ring? You mean like thanks to the magnification that we get from Einstein rings? I don't know that off the top of my head. What's your most popular consensus on how the moon was formed? Another planet-sized thing smashed into the Earth and knocked out a big chunk, which ended up orbiting. You guys can hear that, can't you? Can't our sun be getting pulled by many gravities? How can we know where it's heading? Well, it's orbiting the center of mass of the Milky Way. That's like the Earth is also being pulled by by the gravity of every other planet in the solar system, but it is still orbiting the sun. What does a quantum gravity world look like? We don't know yet. Maxwell wrote about radiation pressure. Can this be used to force objects to move, i.e. as thrust? Yes, and it's been demonstrated. Yeah, absolutely. How do we know the age of a star that's hundreds to thousands of light years away? Basically by comparing with closer stars that we can see more details about, by looking at the way that they evolve, and by coming up with models that adequately explain a star's lifetime, and then we can look at how the observed star Like what part of the lifetime of a star the observed star falls along. Do black holes emit heat? Teensy tiny bit. So what did you get a B in? No, I think it was an A minus. And I think it was in, of all things, math methods in grad school. Does expanding space create more dark energy, making cosmic acceleration self-feeding as the dark energy? Yes, that's the idea anyway. BS or Bachelor's of Science honors in physics I'm studying. Neat. If we can make an unlimitedly large collider, how large should we make it? What could we learn? Make one the size of the Milky Way and then we'd learn everything. We'd figure out quantum gravity. Why doesn't the sun or Jupiter yank the moon from the Earth? Well, the sun is what allows the moon to go around the Earth without like falling out of, and like also go around the sun. Jupiter does affect the motion of the moon and Earth, but not very much because it's far away and it's much smaller than the sun. But yeah, it's the Earth and the sun's combined gravity that lets the moon go around it the way it does. It's the name of the paper on the quantum Riemannian manifold. Go to my website and just go to the research section. Were the most accomplished physicists the most smartest? Highest IQ? Well, I'm not sure if they're highest IQ. I also don't know if they're the smartest. So, yeah. Is the center of our galaxy actually a black hole? Our physics teacher says that isn't proven yet. It is proven. It's not that the center of our galaxy is a black hole. It's that there's a black hole at the center of our galaxy. Could science be different on the other side of the universe, like the laws of physics? It could be, but it can't be different in places where we can see it. Otherwise, we would notice it. I should probably jump down to the bottom. Why do some physicists have beef with string theory? I don't know. Ask them. Is it possible GR and quantum theory will never be unified since we cannot generate enough energy to test that theory? Do you mean is it possible that we will never come up with the right unification? That maybe we will never come up with the right unification. But to say that they will never be unified, I think would be a little bizarre, right? It would be because we still have questions that need conceptual answers. Is there a distinction between being in the center and being at the center? I mean, it just like being the center makes it seem like that the black hole is like some important center and then the galaxy is like around it, but like it's more that like there is a black hole at the center. I don't know. It's just maybe it was just like the kind of the way it came across. Are you taking guests? Yes, I will be taking guests in a few minutes. What do you think about white holes? They almost certainly don't exist. How difficult is it to refine uranium and how much more so per percentage refined? I don't know off the top of my head. Not a nuclear physicist. Would anything fundamentally change if the universe was finite and unbounded? I suspect not. Is there any evidence to back up quantum immortality? No, not in my view. I had to take college physics classes. Any tips? Study hard, do your homework, go to class. The effect of other gravities on an object is proportional to the inverse of the square law. It's proportional to the inverse of the square of the distance. If light, mass, and energy all fluctuate, why wouldn't gravity? Gravity could fluctuate. Is there a difference between being stretched through space and by space? I don't know what the first one means. In your view, does the human mind play an active role in collapsing the wave function? No, I don't think so. But I actually take the many worlds interpretation anyway, so where no wave function collapse happens whatsoever. Does quantum physics horrify you a little bit? No, not at all. Why don't you work for a private company where the big money is? I make plenty of money. Also, I don't want to sell my soul to a corporation. Because honestly, the kind of stuff that I do would probably end up being in, like, you know, surveillance or building bombs or something. Did you make your website yourself? Well, in a sense, yeah, but I just told Claude to do it. So, I mean, I gave it the prompts and then Claude did the actual HTML. Does many worlds necessarily exclude wave function collapse? Yeah. Do you believe intelligent life exists elsewhere in the galaxy? Maybe. It's possible. Why so do you believe the many worlds interpretation? It seems like it's the minimally... It makes the few assumptions about the way quantum mechanics behaves. And it just kind of, rather than delineating some... like the Copenhagen interpretation has like some kind of vague delineation between the quantum realm and the classical world. The many worlds interpretation just assumes that, look, if quantum mechanics is true, then it's true at all scales. We just get decoherence effects, which kind of makes the classical world seem to emerge out of a quantum scale. Yeah, your work would be a guidance system for none of your goddamn business. That's true. Exactly. All right, so, God, I'm so hungry right now, but that's okay. So I am going to transition the stream over to subscribers only questions. Now anybody will be able to watch, but subscribers and you know, members or whatever the $4 or $5 a month membership thing is, I'm going to transition it over to that, to only those people will be able to ask questions over text. And I'll also be taking guests. So give me just a minute. I'm just going to do that transition really quick. It just takes a second. And this is just as, oh no, it's been on members. Wait a minute. Has it been on members only this whole time on the Dr. Blitz Debunks page? I hope not. Because then I would feel very silly. Really hope not. Otherwise I would have wished that. Please. Okay, no, it wasn't. Okay, good. And let me turn it on. Okay, so it's already been turned on Twitch. Thank you, Besso. And then I'm just going to restart the TikTok live. So if you still want to watch, feel free to rejoin in 2 seconds. And then I click go live. But then I go down to superfan only chat. There we go. Everybody can watch. Welcome, welcome. And now we'll also be taking guests, of course. From feeling the future with geometry, I developed a geometry that can predict earthquakes, seizures, human actions, and many more random things. I show proof. Need more eyes on it. Well, I appreciate the super chat. It's not a thing that I do. I don't really do the whole, like, reviewing the work of randos, basically. Now, by the way, if you are a member, if you're a super fan on Discord, please let me know. And please see if you can find like the super fan zone or whatever it's called, the super fan club zone, and there should be like a place where you can access a Discord link. It should be added in, and then you should be able to click on it and get a role automatically. Let me know if you can find that. Let me know if you can see it. Let me know if you can click the link. Let me know if you get the role, because currently nobody has yet. Do you think AI will have a larger and more prominent role in space travel? It might. I mean, I don't know what kinds of problems need to be solved. Oh, I don't know why that just popped up. I don't know what kind of problems need to be solved that, like, in space travel that AI will help with. Why does it keep popping up? Okay, I'm a member in the wide view, but not the phone view version. That's fair. Yeah, so unfortunately, it's not cross-platform. I started the wide view version before they introduced the cross stuff, and I like having the two separate channels, one for more sciencey stuff and vertical, and one for more YouTube friendly stuff like debunky stuff and horizontal. I like kind of keeping them separate. Let me just make sure that nobody has... Yeah, it's still not working, the automatic role assignment. Oh, wait a minute. Wait a minute, who is this? Okay, never mind. That's just the app. All right, let's bring up a guest. What do you think is causing the Great Attractor? I suspect it's just a big bunch of galaxies that we can't see because our galaxy is in the way. But your guess is as good as mine. Hey, how's it going?
Good, how are you?
I'm doing all right. What questions you got for me?
Good. I don't know if you remember me from like 2 weeks ago. I was the math or philosophy guy. I was like kind of having troubles deciding that. I ended up just choosing like physics because
So neither of them? Seems good.
Right, yeah. Yeah, exactly. The question is, should I double major with math? And the second question is, what should I be doing over the summer to like sort of prepare?
Should you double major with math? I mean, if you can, yes. It's going to make your life, like, it means that you'll be taking a lot of math and a lot of physics. And it's like, so I double majored with math and physics. And I was taking 18 to 21 credits every semester.
Oh, okay.
But I flourished on that because it kept me busy.
Right.
But, you know, it's a lot of work, right? Doing a double major in 4 years especially is a lot of work. So if you can, do it. Otherwise, do a minor in math. And, you know, you'll at least get more exposure to most math than like the straight physics majors will.
Okay, good. The second part, should I just be working on like a bunch of calculus all summer? Because I'm...
Oh, yeah. Yeah, that's probably a good way to start. I mean, like, honestly, the thing is when I was an undergrad, when I was a freshman in particular, the thing that most, and when I was teaching undergraduates as well, the thing that hurt students the most was that they weren't able to follow conceptually what I was doing with the calculus that I was doing. Because I would often just use calculus as a tool rather than as a means to its own end. And if you can't follow its use as a tool and understand what's happening conceptually because you have a good grasp of what's happening mechanically, then you're going to fall behind.
Makes sense. Okay, that's kind of what I had in mind. No, that was pretty much it. I hope to, be able to get my PhD one day. Either way, in math or philosophy, I was going to pursue a PhD, but I started reading this physics book, and I'm like, okay,
Which book?
I think this. Let me. I don't know if that's a good one.
Sorry, you cut out. What was it?
It was Young Friedman, University Physics.
Oh, yeah, no. I mean, that's not a pop science book. That's just a textbook. Young and Friedman is the book that I have taught out of and I used as an undergraduate. It's a standard university textbook. So absolutely, It's a good book. I think that it explains things very well.
Perfect.
The other thing that somebody mentioned in chat, which I should mention, also make sure that I mean, if you have no problem doing calculus, then you probably have no problem doing algebra, but make sure that you're also comfortable with vectors as well. Especially vector calculus, if you can.
Gotcha. Yeah, I mean, I just finished Calc 1, so I mean, I'll probably be revisiting a lot of that stuff.
Good.
I'm doing Calc 2 over the summer and then preparation for the fall. But yeah, I appreciate the advice, man.
Yeah, of course. Good luck.
Love your work. Yep, thank you.
Appreciate it. Let me make sure that I didn't miss anything. If you think you can predict pretty much all human behaviors, then you should test that against the stock. Oh, that was for a super chatter, my bad. Members unite. Indeed, members unite. Let's talk to Gissa. Gissa, how's it going?
Yo, what's up, bro? I'm doing well, and you?
I'm doing all right. What questions you got for me?
Yo, my biggest question is, I'm like atheist, but I'm so interested in like the Big Bang. Do you know like something? What happened really now? How did the expansion like happen?
This is an open question. It's we don't have a definitive answer yet.
But what do we know?
We know that it did expand. We don't know definitively why it expanded.
But I read something about electrons, neutrons that collided or whatever.
Nope, it wasn't a collision of stuff. The universe probably didn't have matter as we know it in the very early phases of the universe.
Yeah.
What may have caused it is something called inflation, which drove an even faster expansion in the very, very, like, before the Big Bang, and then the inflation ended and it dumped energy into the hot Big Bang, and that caused the expansion. But this is not, no, nobody really knows the answer to this question definitively
But
anyway.
it's like the singularity theory. Is that correct? Like
Most physicists are going to say no.
Oh, so I can't say, okay, the universe expanded from one singularity.
Yeah, that's not really the consensus, no.
So basically we can say, okay, there was like a hot dense place that expanded, and we don't know how and how it got there.
Yep.
And do you ever think we get the answer?
Yeah, I think so. I think it's a question that can be answered. We just don't have it yet.
And what's like the biggest problem? Because I read about like quantum gravity.
Yep,
Quantum,
that's the biggest problem.
And what's that? Can you explain that?
We don't know how gravity works at the microscopic quantum scale. And you need to know how gravity works at the microscopic quantum scale, because 13.8 billion years ago, the universe was microscopic.
Yeah. Okay, sure, yeah. Sounds logical.
Anything else?
Let me think about something quickly. Is it true that if you have like a black hole, that inside the black hole is like a possibility for another universe, and if you can make black holes, you can like code those the laws of nature of that other universe?
It's a pretty fringe idea. It was proposed by, what's his name? I'm forgetting his name. This is called
Is it Einstein?
No, that wasn't Einstein.
Okay.
Whole natural selection. There's a guy, Lee Smolin, I think is his name. Yeah, it was proposed by Lee Smolin. It's pretty fringe, and there's not really any good evidence to support it. There's not really any proposed mechanisms for how you would have a universe inside of a black hole anyway. So I would say generally no. It's not really like something that a lot of people take seriously.
Okay. Crazy, man. What's like your biggest, like, what do you find most fascinating about like what you know?
The same stuff that you do. I'm curious about the black hole, or about the Big Bang stuff too.
Oh, okay. Cool, man. Okay, now thank you, man. That's nice.
Of course. Thanks for being here.
Hey, ciao, bro.
Ciao. There were some questions as well in the text chat. Using math as a tool, thank you, Chase, by the way. Using math as a tool for physics rather than just math because a math question was asked is an underrated skill. It simplifies physics things so much. Yeah. So this is the hardest thing for people to learn when they're first learning physics. It's the hardest thing for people to pick up on. You'll have a lot of people who say, "Oh, I was good at calculus," but what they mean is that if they were handed an integral, they could figure out what the integral was. But it doesn't mean that they actually like know what an integral means or what it's used for. And that's the skill that you have to pick up when you want to learn physics, because physics doesn't just do math for its own sake. Physics uses math to answer questions about the world, or about the ways the world could be. From Pappy, why not quantify shape distortions instead of forcing surfaces to be perfectly angle preserving? Well, I mean, you can. That's just not conformal geometry. Conformal geometry is valuable because there are a lot of structures that have conformal symmetry, and so studying those kinds of structures is important. Let's bring up Sivasesta Quenta Esperana Eunice. It's a long name. Sivasesta. I don't know how to say her name.
Sorry.
How's it going?
My name is Omar.
Omar, how's it going?
Yeah, that's just a Spanish. It means if you see this account, I use it to study physics.
Okay, fair
That's
enough.
just what it is.
All right, so
Yeah.
Omar, what questions you got for me?
Yeah, so look, I'm a first year. Well, I just finished first year. I'm double majoring in applied math and physics.
Okay, cool.
And I want to ask your opinion about this double major. You think it's worth it? So the applied math is mostly, it's going to be more like machine learning, deep learning, optimization, very industry heavy.
Yep.
And then I have the physics where you have tensor calculus, you have quantum physics, general relativity, like very physics theoretical. I took this double major because in the future I'm very interested in working on quantum computers.
Yep.
But I don't think it's so. I'm trying to ask from an opinion from a professional like you, if this is a good idea to put so much effort in two different majors. It would take me around 5 years.
So you might be more well served, and I don't know this for a fact, but you might be more well served doing a computer science degree and a physics degree. if you want to learn about, if you want to do quantum computer stuff, applied math is very much more, and you know, this is just my impression. I've never done an applied math degree, but my understanding is that applied math is a lot more about, you know, like learning numerical methods to solve problems, but that's not really what the what you're going to be doing for a quantum computing research area. So hopefully that informs your decision. Now, this, by the way, this is not to say that applied math is not a worthwhile degree. It just won't be directly implemented unless you're solving systems numerically, or, you know, you're, unless you're, there are a certain set of skills that you'll have which will be useful, but they might not be directly useful.
Yeah, so the reason why I took applied math instead of computer science is because there was more intersection, so it would make it possible to finish
Yeah, that makes sense.
5 years. Because a computer science, I would have too many computers stuff, which I don't hate it, but I'm not very heavy into programming as a whole.
It's not going to hurt you getting an applied math degree and a physics degree. It's not going to hurt you.
Okay. And also, I'm very interested, of course, in getting into research. Would you, because it's very difficult, because now it's very ambiguous. Whenever you ask someone, they only tell you it's your first year. Wait, you know, you just finished your first year. Can you recommend me maybe a path, or where can I learn how to get involved into research? For now, I joined the research team in my university, but not much more.
Well, yeah, so getting involved in research as an undergrad is tricky, and especially just as a first year, you're not gonna be able to contribute much unless you already have some skills. So when I was an undergraduate, after my first year, or near the end of my first year, I got involved in research simulating some particle physics stuff. But I didn't know anything about particle physics. I just knew how to work with software. And the professor I was working with was on the older side. And so he basically kind of, myself and a classmate, he kind of relied on us to be able to figure out all of like the niche computer stuff that he wasn't as familiar with. So like I was, you know, reading software manuals and running simulations and stuff like that, but I wasn't really doing physics, but I was still helping. So if you are going to get into research, especially early in your university career, that's what you'll end up doing, most likely. And so you should probably go talk to people that you could do coding work with or run simulations with. You're not going to be doing theory work after your first year, right?
Yeah, of course.
You could also do like machine work. You could go find a lab where they need you to do like the actual grunt work of building things, and then you could go do that too.
Yeah, that's for now. That's the only thing I've done. I went to like prepare the experiment, write down the uncertainties in the blackboard, things like that. For now, that's all I could do. Okay,
but that's pretty normal.
Perfect. And then if I can get your opinion of quantum computing as a career. For now, that's what most interests me, why I'm doing this double major. If you think like it's worthwhile.
Quantum computing isn't going anywhere. So I think that it's definitely a worthwhile career focus, especially if it's interesting.
Yeah, of course, like mostly I know in Vienna, the thing I'm applying right now for the trying to apply, of course I have to get my curriculum ready. They have the labs for qubits.
Yep.
There. So if that's, you think, a good career path, I need the opinion of someone like you.
I mean, definitely working in quantum computing is going to continue to be a large industry for a long time.
Well, perfect. That's all I need. Thank you so much.
All right. Well, Omar, best of luck.
Thank you.
From Akira the Cat, would you rather give up Akira's the cat? Sorry, would you rather give up realism or locality? I'd rather give up realism, to be honest. Locality seems sacrosanct in some way. I don't know why, but it seems more sacrosanct than reality does, or than realism does. From Will Day, we have Will Day is back. Will Day, welcome back.
Hey, Dr. Blitz.
Oh, why are you coming out of my monitor? It's not where you're supposed to be coming out of. All right, try again.
Hello?
Much better. How's it going?
All right, doing all right. How you doing?
I'm doing okay. What you got for me today?
All right, I brought out a list this time, so I'm more organized. I did want to ask, what are the most important group theory theorems and concepts that are used in physics? Specifically,
Oh, theorems? Physicists don't use theorems. I mean, they will implicitly use theorems. The most important concept that you'll see in physics, depending on what type of physics you're doing, if you're in particle physics, it's going to be I don't even know if there's a named theorem for this, but the fact that there are irreducible representations, it's going to be representation theory stuff, by the way. It's going to be representation theory stuff. It's going to be results about representations of groups and their algebras, especially Lie groups and their algebras. And tensor products of those representations and so on. That's at least in particle physics, that's one of the more useful things that you can use. The actual theorems that at least in my work, and I'm sure that this is not the case in like string theory and stuff and in super sophisticated quantum field theory, but at least in my work, we don't really work with groups in the sense that mathematicians work with groups. It's just not very common. Like the most common groups that you're going to see are going to be, typically they're going to be gauge groups or Lie groups rather. And that's kind of it. So if it has to do with Lie groups, then you might find something useful, but unless you're doing some really fancy string theory with some weird symmetry groups or something like that, or if you're doing some sort of like algebraic quantum field theory, then you might run into some other things too. But it's mostly representation theory is what I've seen.
Gotcha. Yeah, that's definitely my favorite field of group theory now, since I did my final research project in that for my bachelor's. But actually, you mentioned something in there that I was wondering about too. How do you take a product between two tensors? I mean, I'm confused.
You put
about
them next to each other, and then you call it one thing.
Okay.
That's literally it. You just put them next to each other, because the point of a product between tensor spaces, or a product of tensors in living in a product of tensor spaces, is that it's just that it becomes it's literally just like two independent things kind of glued together. They don't talk to each other. That's what it means to take the product. Now, there are ways that you can kind of combine the product in a way that they kind of do talk to each other, but that wouldn't be a tensor product anymore.
So actually, as it regards the field equations, I know, are you multiplying tensors in that equation at all? Or is
which field? Like you mean the GR?
Yeah, the classical one, I guess.
So in Einstein's field equations, you just have there's a specific tensor called the Ricci tensor, which is a symmetric rank 2 tensor. And it's a, you take the symmetric tensor product of the tangent or of the cotangent bundle, then you get the relevant tensor space. And so what all the Einstein field equation is saying is that particular tensor, which depends on the metric, is related to the stress energy tensor, which is the same kind of tensor.
Oh, okay. Okay. I also, you talked a little bit about the Poincaré group earlier, and I was completely confused by when I read the Wikipedia page on that.
Yeah, so I always get the Poincaré group and the Lorentz group confused, which shows you how much I know about this stuff. But let me just make sure that I'm talking about the right one. The Poincaré group is the one that's supposed to have I should have been talking about the Lorentz group, but the Poincaré group is a subgroup of the Lorentz group. So the Poincaré group is just the group of it's the group of, it tells you it's the group of isometries in the Minkowski space. It is basically just telling you how you can rotate and how you can boost. And that forms a group because you could rotate and then boost, you could boost and then rotate, you could rotate, and you get a different rotation. So it's a group.
And so it's isometric too?
It's the isometry group. Space? It's the isometry group of Minkowski space. So what an isometry group is it's just the group of transformations that you can apply without changing the underlying spacetime. So you can rotate Minkowski space without changing it. You can boost Minkowski space without changing it.
I thought isometries had involved a conservation of distances between two groups.
Yeah, that's what I mean. Yeah.
Oh, okay. And then you said something else in there. The Minkowski space. What was that again?
Minkowski space is the space-time that is talked about in special relativity. So it has no curvature.
Okay.
It has a metric. The metric has indefinite signature. So it has if you're a good scientist, it's negative, positive, 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 because it's 4-dimensional, and there's a 1 negative time-like direction and 3 positive spatial directions. But if you're a bad physicist, it might be positive, negative, negative, negative.
Gotcha.
Because some people just hate nice things. But yeah, that's what Minkowski space is.
Oh, okay, cool. All right. The other question I had is, do you know, or can you explain
Wait
what
a minute, hold on.
Banach
I got this backwards again. I'm so sorry.
Oh, here.
The Lorentz group is the smaller one.
Oh, okay.
The Poincare group includes translations, not just rotations and boosts.
Gotcha. Okay, cool.
I always get them mixed up.
Nah, that's all good. You are more of an authority than I am, so I'll take you at your word for all that stuff. But yeah, my other question was, can you explain what a Banach space
Banach
is?
space. Banach space. Probably not well. That's very functional analysis stuff, and I just don't do functional analysis.
Oh, okay.
Banach spaces do show up in quantum field theory. They're kind of like a generalization of Hilbert spaces, if I remember correctly.
Gotcha.
And they basically let you do Hilbert space things, but for functions.
Oh, that makes sense. Yeah, because Hilbert spaces are vector.
Well, I mean,
right?
so depending on like, Banach spaces are large. It's a larger class of spaces. I guess all Hilbert spaces are Banach spaces. Not all Banach spaces are Hilbert spaces.
Gotcha. Okay. Cool.
I hope that I'm getting that right. God,
question.
I haven't thought about functional analysis forever.
Yeah, I was surprised to hear that you had studied that because I looked into it.
To be clear, I took one class on it 10 years ago. Maybe not 10. Yeah,
okay,
10 years ago. So it's been a while.
Gotcha. That brings me to this question. What are your favorite pure math subjects besides obviously geometry and conformal geometry?
That's it. That's all. That's my favorite thing. No, I did take a class on number theory, and I thought that was really fun when I was an undergrad.
Oh, cool. Nice. All right, just one last question.
Sure.
What is dark matter's mathematical description? Like, what are the mathematical tools that you have to use to describe what it is?
So
I guess
typically, the way that it's usually described as is just as some sort of cold dust that is non-interacting, and that's it. So it doesn't interact with electromagnetic. Well, yeah, I mean, you could. There is a stress energy tensor that you put on the right hand side of the Einstein field equations that describes cold dust. There's a nice way to describe it. It's pressureless. It has a mass density or has an energy density. You can write down the stress energy tensor for it, and that's what you plug in. And then yeah.
GR to it like that. I guess it is something it's non-interacting with like the normal particles of the standard model.
Like
right?
we don't know what it is. Like they're like maybe someday we'll have like there's a bunch of hypotheses. Like you can look at like axion models, which is one proposed mechanism or one proposed version of what dark matter is. And then there's like a whole like quantum field theory of axions, and you can go look at WIMPs, which are weakly interacting massive particles, and there's a whole quantum field theory for WIMPs. And you can go look at primordial black holes, and there's a whole GR description with some quantum field theory, sprinkled in for primordial black holes, but we don't know which of those are correct. What we do know is that it behaves like a cold dust that doesn't interact, except gravitationally.
It does. Oh, okay. I was about to ask that. Yeah, it does interact.
Yeah.
Gravitational GR and stuff. Okay. I guess just if you have another time for one more, this would be probably really quick.
Sure.
I did a funded project actually in my undergrad that was trying to find a link between hypergraph theory and differential geometry. Do you know anything about hypergraph theory? It was really, I had done a graph theory project and kind of knew a lot more about that than I know about differential geometry, but I couldn't find any kind of connection. I had a theory about like potential energy surfaces potentially mapping to like the structure of a hypergraph, being able to define a potential energy surface, which is like something that you can look at in a differential geometric sense. But,
so I don't know anything about graph theory. So gotcha. I wouldn't be able to help you there.
Okay. Well, that's all good. I'm out of the project now though, anyway, because I graduated and unfortunately didn't make
Fair.
my PhD this time around. But I'm staying
always
sharp
next
on
time.
my math and everything. But
Sounds good.
Yeah, flying for next year. But thanks for having me on.
All right,
It's good to
take care,
talk to you
Will.
again. Always good. You too.
I'm going to answer some questions, and I'm going to bring up Dr. Joe. Would you rather give up reality or locality? I already answered that. I'd rather give up realism. What are your thoughts on Hawking's no boundary proposal compared to the big crunch model? I like the no boundary proposal. I think it's quite nice. We mostly use Lie groups and weird string theory as well. Yeah, no, but you guys probably use more results from more actual deeper results about Lie groups rather than just using representation theory. It'd be awesome to see new debate content with flirts to hang out. I think you'd get a lot of viewers and interaction in areas of debating moon landing deniers specifically, as well as the hordes of peeps asking about missing scientists. Yeah, we'll consider it. Maybe we'll try that out on Thursday or something. We'll try a new topic. Why does the message not show up? I already answered the message. I'm just not clicking it because it's not a super chat. That's all. Does the fact that dark matter doesn't interact with electromagnetism mean that it's cold? No, you could have hot dark matter. It's just that hot dark matter behaves differently from a thermodynamic point of view than cold dark matter does. They just behave differently. I usually send people to Georgi's book for representation theory side of groups. Yeah, that's exactly what I do. That's actually where I learned the representation theory stuff. All right, let's talk to Case McCullen because Dr. Joe dropped out. Case, how's it going?
Hey, how are you, sir?
I'm doing all right. Case, what questions you got for me?
Man, it's good to talk to you. It's been a long time. I know you won't remember me. You talked to a million people. But,
Sorry about that.
we mostly agree on most things.
Good.
But I have a question, and before it has to come with a disclaimer so that you understand and know that I understand that the world is a sphere. Okay. And
I'm glad that we agree on this.
Okay. And the reason I have to make that disclaimer is because what I'm going to say next, I need a logical explanation on why this is happening.
Mm-hmm.
I think, and just as a part of that disclaimer, I want to say that I don't think that anybody that's taking money from government is not answering to said government. So whether or not we are going, I'm not arguing that space is real. I'm not arguing that planets are real. I'm not arguing any of that. I'm just simply saying I think that we're not getting the whole truth, just like every other government agency. There may be base truths to it, but I think for the money that we are spending, I think it's overspending for what we're getting. In other words, I think that they have a budget that they could say that they are doing a lot of different things that they may not necessarily don't have the capability to do. I can remember being a younger man.
So why not just ask the question?
Well, I just mean that I remember being taught that the Van Allen belt was almost impossible to penetrate through. And now if
you
Google
didn't. Unless you're like 70. No, you didn't. No, you don't remember that.
I mean, I'm 47.
I mean, if you were taught that, then your teacher was just incompetent because we've known that this is not. We've known that this is easy to penetrate. Like it's not a solid barrier. We can get through no problem for decades.
Maybe we know more about that. Right?
No, we've known this since the 60s.
Okay, fair enough. We've known it since the 60s. Then my question has to do with our atmosphere, and actually, the free fall of the ships after they come back in and they start parachuting in.
Mm-hmm.
Now you can watch multiple on YouTube's how they come in. They fire off usually 2 primary chutes, and they run mostly behind the craft. They're very close to.
The chutes are behind the craft. Yeah, they're called drogue chutes.
Correct. Now, if you've ever been to a drag race, I just give you a quick reference. When they release their parachutes at like 150 miles an hour in an eighth mile, etc., when they release those parachutes, they're going the same way, directly behind the thing. So as a physicist, maybe you can kind of paint me a picture on why it looks similar in those 2 instances. But here's what happens. Something weird happens. When the 4 parachutes come out, right, then they separate and even will drift sideways, and they still are full of air. They're not getting jumbled up or bundled up.
I don't know what you mean by drift sideways.
Well, if you look up the SpaceX on YouTube, there's a video, and it's showing the whole entire thing, and it's going to the left. You can see behind it, it's going to the left, and all the 4 parachutes, they're all full of air, right? And nothing is rippling, nothing is doing anything. And then before the moment that it hits the water, it relieves tension off of the wires. Now, it's very
I'm not really
strange.
sure what you're referring to, but I just pulled
WB-57
up
high
the,
altitude plane, and there you see it on your screen.
I just pulled up one. It looks like, so we have the 2 drogue chutes coming out. Oops. I'm looking for, okay, this is the, yeah, and then you have the 2 parachutes come out and they're just hanging there. Doesn't seem like an issue. I can show you what I'm looking at, and maybe you can tell me what you're talking about, because this kind of looks the same. So we have.
You see here where it's falling?
Yep.
Can you put me on the big screen real quick?
No, I cannot, because you're on 4 platforms.
Do you
But you
see
can
where
you can see what I'm looking at, right?
Here, where all 4 are separating?
Sure, I guess. Yeah, I
They
think so.
shouldn't be separating, right?
Why not?
And then they come back together. And then if you watch, right when it hits the water,
if
they'll
they're
come apart
angled,
again.
why couldn't they be separated?
But the whole craft is also floating. If you're a physicist, you should be able to tell me how come that while this craft is moving to the left or to the right 15 degrees because the wind is blowing, why is there no effects on the backside of these? There should be some indentation. It looks funny, man. It looks funny.
Okay, it looks funny. Try simulating it yourself. See what happens.
Anything you throw off your roof is going to trail directly behind the craft, just like
not if the parachutes have angled
These parachutes
wires.
should be tangling up right now.
Why?
Right?
Not if the lengths of the parachute wires are different. Right? If the inner side is shorter than the sorry, let me get this right. If the outer side is shorter than the inner side, then it'll pull them out.
Continuing to descend under those chutes. We just passed 500 meters.
Doesn't make sense. How come the parachutes are all, then they'll come back together, but watch, they don't touch. You'll see them come together and then watch. Shouldn't they be running into each other right now? Look, these up
here.
Not
necessarily.
I mean, those wires aren't keeping them from touching. Physics should tell you that whole thing.
If the wires are different length, then sure they can. They will direct the angle of the parachutes come out.
That other one back there in the back, they're not running into each other. Do you see what I'm saying?
Not really. It's very small.
They're going back and forth. Nothing's tangling up. Nothing's running into each other. And then what you're going to see is when this craft hits the water, right before it hits the water, is when you'll see it looks like it already landed and the tension comes off of these wires.
It seems like personal incredulity. It's kind of hard to see, though.
Well, I'm sorry. I'm trying to...
Is 100 meters above the...
It just doesn't make sense why, if it's falling straight down or the wind's blowing it to the left and right, why these...
Well, it's not clear that the wind is blowing it to the left or right?
Well, I mean, there's other
ones. But the point is that like the parachutes are angled; they're launched out at an angle, so of course them falling down is going to spread the parachutes out.
That one does. There's other ones where it shows the most recent where they'll fall before they hit the water, which doesn't make sense at all logically, right? They should fall when the water. That one, it acted correct. But do you see how now they're all just falling down and there's no wires on that?
I can't see what you're showing me.
Well, like I said, you can look. It just doesn't make sense to me as watching.
Okay, well, look, so there are a lot of things. So all I'm going to say is, like, I don't know specifically what you're referring to. All I can do is look at the small thing that you're showing me. I pulled up a SpaceX thing and it looks normal.
You ever thrown a little army man with a parachute as a kid?
Yeah.
Have you ever done anything like that?
Yeah.
Have you tied 2 or 3 or 4 parachutes on it and then tried to do it?
Yeah,
they tangle up.
These aren't just all tied to the same place. These are tied and angled in a certain way, and they're designed in a certain way so that they can be buffeted out by the wind, so they come out at different angles, right? The point is that it seems like that this is a thing that you don't understand, and because you don't understand, you're assuming that it's fake. But it could just be that you don't understand how aerodynamics works or how the design of these parachutes work.
Well, like you said, it's something you can test.
Yeah, you can test it. You can do this yourself.
Except the problem is it's coming in way hotter than any race car where the parachute trails behind it.
Yeah, that's true.
And that's all I'm saying. Like 2 to 3 times as fast. What, like 300, 400 miles an hour? It's coming in. And then what is the temperature?
I actually don't know, but yeah.
So the temperature of this thing was just like multiple thousands of.
No, it wasn't. The whole point of the ablative heat shield is to prevent it from getting hot.
So it never gets hot at all then?
No.
There's no scorching on the outside from chemical burn?
The ablative heat shield, if it's working properly, is going to ablate, which means that it's going to burn off, taking the energy with it, keeping the rest of the capsule cool.
In that burning, there should be charred black on the outside of the craft for that reason.
It'd be on the bottom. That's where the heat shield is.
Right, and it would be hot there. Like there would be a raise in temperature.
The ablative heat shield, right? The ablative heat shield, when it gets hot, it blows away. That's what an ablative heat shield is for.
Our metal is so advanced.
This isn't a metal.
Ablative
heat shields are not metal.
So it can fly through the Van Allen belt with no problem.
Yep.
It can also get to
the Van Allen
thousands of
belt
degrees.
is not a solid thing.
It could fly into the sun basically, and we would be okay.
No,
is what you're saying.
No, because the source of the energy is coming from compressing gas in front of the vessel as it's falling, in front of the capsule as it's falling. And so if that's the place that's getting hot, all you have to do is just design a material that basically explodes when it gets beyond a certain temperature, taking that heat with it. That's what an ablative heat shield does.
So then how come we see these things coming back to space? And obviously there's no steam when they land, I guess
because they're not hot.
Okay. They're not hot.
That's what the ablative heat shields are for.
Right. And there's no marks on them. When these people come to look and you see this perfectly clean craft, what's your explanation for that?
Why would there be marks on them?
Okay. Well, like I said,
it sounds like you're not willing to accept what the answer is. You just
let me ask
want to believe the conspiracy.
I'll give you an example of your logic. Do you believe in evolution?
I do, and that's not the topic of this live stream.
And so when NASA comes to you and says that they're made by aliens, that you were made by an alien and introduced through divine intervention DNA, what are you going to say then?
I don't think NASA's going to say that.
And if they were to, just hypothetically, what would you say? Would you switch your beliefs?
If they provided evidence for it, sure.
So it just shows that your belief system is malleable to anybody that produces whatever you think evidence is.
Yes, that's called being a scientific skeptic.
Right. So
you
I could
adjust
just
your beliefs in line with the evidence.
Get a peer-reviewed study if I have enough money, and you'll say that that's true.
Peer review doesn't cost a certain amount of money. That's not how peer review works.
No, if I have multiple scientists saying it, not just one, right? Because I guarantee you, NASA's not just, they're going to come with some receipts.
Yeah, if they have compelling evidence, then yeah, that would be the view.
But what if it's all fake? How would you know?
Look, so
how would you know who's going to be able to keep them at bay and say, hey, you know what?
Fortunately, scientific evidence is repeatable, so we could check.
Well, so what you're saying is you'll believe we came from evolution or aliens.
If there's sufficient evidence, if the evidence is compelling, then absolutely, I will believe where the evidence leads.
Or skewered. What if the studies are and the data is skewered?
And what if we're all a brain in a vat? Like, look, the best we can do is just believe
any lie.
What I'm saying is that I'll believe the evidence.
Well, I don't know what to say, man. You know, I mean, anybody can.
It sounds like the alternative is not believing the evidence, which seems worse. But look, this is not a debate live stream. This is a question live stream.
I understand that. I respect you.
I appreciate. Thanks for being here. There are a few questions, and I'll bring up Dr. Joe. I just want to make sure that I didn't miss any questions. Have you talked about constructor theory? No, I'm not familiar with it. If you were naked, the belts would probably fry you, sure, but you were inside a spacecraft. No, they wouldn't fry you if you were naked. The amount of mass contained in the Van Allen belts is about the mass of a donut. Right? Like, there is basically, like, you would get some radiation, but you're getting radiation anyway, so that's why you try to pass through quickly. You would not burn at all, not whatsoever. There's not nearly enough mass in the Van Allen belts to cause you damage. So the total amount of energy in the Van Allen belts is like if you took a donut-sized mass and then you heated it up to a few thousand degrees Celsius, and then you spread that out over hundreds of thousands, or actually I think millions of cubic miles. There's just not enough heat. Just looking for more questions. Is this Casio? Maybe. My work is funded, but I've never had a government worker tell me what to do or what results I should get. The funding is to do research. The exploration is the result. I did not answer to any government people. Yep, when my work was funded by the government, I was the same way with me. People should be skeptical reading any study. No one takes them at face value without reviewing. But yeah, so, I mean, the important point is that when we talk about a consensus of data or a consensus of evidence, is that the right phrase? we're not just talking about one singular study. We're talking about a collection of studies. So if NASA comes out and says, look, we have all of this data, all of these independent peer-reviewed pieces of data that make this claim, then yeah, I'd probably believe them if the evidence is compelling. Can you answer my question about the no boundary compared to the big crunch? I like the no boundary. I think that singularities are probably non-physical. Are the quantum fields thought to be continuous and the excitations are quantized? Yeah, that's roughly the idea. All right, let me bring up Dr. Joe. Dr. Joe, it's good to see you.
Hey, you alright? Can you hear me?
Yeah.
Nice. So probably the simplest question you'll get today, but essentially, obviously at our med school, we get a lot of talks about various drugs. And so I end up seeing content about new drugs that come out online. And there are sometimes these people who will say there's this new drug, and then they'll say it's quantum medicine.
Oh boy.
And my simple question is, because I never get an actual answer, what does quantum actually mean?
In that context, it means nothing. It means literally nothing.
Okay.
What quantum means in the physics context is generally it means something to do with quantum mechanics, which is not helpful, okay. I understand. But essentially there's a straightforward, not straightforward, sorry. There is a kind of a not folk understanding, that's not right either. There is a kind of a consensus understanding of what quantum mechanics, quantum field theories, quantum theories are in the physics community. So when somebody wants to talk about some feature of something that has those structures, then they'll use the word quantum to describe it. And these are usually very, very microscopic things. I've never seen somebody talk about quantum medicine in a way that wasn't like magical woo-woo stuff.
Yes, exactly. But this is why I was trying to, if I knew the actual definition, then I could discern. I mean, I guessed it was nonsense, but when someone approaches me and says this is quantum, I don't have a reasonable rebuttal to explain why it's rubbish.
So quantum, literally quantum just means like a small amount of, right?
Okay.
And the reason why we call quantum physics is because in the early 20th century, there was talk of like quanta of light, like little packets of light. And those were called the quanta of the electromagnetic field. Now, it's not really used that way anymore. That's not what people say when they're talking about quantum medicine. They're not saying a little tiny amount of medicine, right? What they're saying is that our medicine is somehow invoking quantum mechanical features of the world or something. And almost certainly that's not the case.
Yeah, I was going to say, usually when I read the paper, it's just basic chemistry.
Yeah.
But,
no, that said, sometimes basic chemistry does involve quantum mechanics, like all of this orbital stuff, like that is quantum mechanics.
Sure, okay.
But, I would be very, very skeptical of somebody kind of using quantum as a buzzword in that regard.
Okay, that makes sense. Okay, that was it. Thanks
All right, of course. Thanks for being here. So I just got a message from Grimlock saying that the TikTok to Discord thing link is working. It says I joined, hopefully it's working, went to Fans Journey and click the question. So if you go to the Fans Journey, click the question mark in the corner, it'll have a link to the Discord on TikTok at the top of that tab. So if you are a super fan on TikTok, try doing that and then see if you can get the automatic role on Discord. Currently nobody has that role yet, but I'm hoping that somebody will be able to get that eventually. So we'll see if we can get that working. But I apparently you can only do this while I'm live, which is why I'm trying to work this out now rather than working out later. So if you are a super fan and you want to join the Discord server with like a special role so you can get some special perks, I guess there's a question mark down at the bottom. There's like a little question mark in the corner. It'll have if you click on that, then you'll get a link to the Discord on TikTok at the top of the tab, and then you can click on that, and then you should join. And then you should get an automatic role when you join the Discord server. And it's just my Discord server, but you'll get a special role. But currently nobody has done it yet, or at least it hasn't worked for anybody. Usually quantum now just means using quantum mechanical principles or mathematics. Yep, that's the basic gist. From Wilday with Wilday sends medicine as molecules equals quantum medicine it's better than regular medicine. True. Yeah, that's the basic idea. What do you think is the least intuitive math fact theorem? Math fact / theorem. The Banach-Tarski paradox is very, very weird. I don't like that at all. The Banach-Tarski paradox says that if you throw away the axiom of choice, sorry, if you allow the axiom of choice, then you can disassemble a sphere into a finite number of pieces and then reassemble those pieces into 2 identically sized spheres. One quantum of cheeseburgers is equivalent to a quarter pound. True. Very, very true. Let me drink some water. Why does breaking entanglement release energy? I don't think it does. Thoughts on the Prague CVUT Quantum Technologies program? I'm not familiar with it, so I don't really have an opinion on it. Pi equals 4 in a Banach space. My intuition doesn't like that. Well, there's that too, but that's not the... Yeah, well, okay, fair. All right, let's bring up another guest. We have some guests on TikTok, and we also have some guests on Discord. Let's bring up a guest from Discord. Let's talk to Big. Big, how's it going? You're on. Big? Big, are you there?
Hello?
Hello.
Hello, dude.
Big, what questions you got for me?
Well, I wanted to ask you about, you know, the whole, hold on, wait a second. Excuse me for a second.
What is happening? Anybody know? All right, I'm gonna let you go. I'm a little bit spooked, not gonna lie. Grimlock, so it seems like you didn't get the, seems like the roll didn't automatically make it to you, which is confusing. Because there should be a, yeah, there's a roll that only a few people have right now. And none of them are the TikTok member roles, which is annoying. All right, let's answer some questions and we'll bring up another guest. All right, okay, let's just bring up a guest from Discord. Let's bring up Luke. Luke, how's it going? Gotta unmute yourself, by the way.
Hey, can you hear me?
I can. Luke, what questions you got for me?
Very nice to meet you.
Likewise.
So it's about what you're talking about yesterday. Like you said, the universe is expanding. You talked about your paper where it's periodic and on average 0, right?
Sure. It sounds like you want to debate. Today's not a debate day.
No, not at all. I have questions about it.
Well, wait a minute. I mean, you did just call my paper idiotic. So, like, do you think that that's a good way to...
Periodic, sure. Periodic expansion, and the average is 0.
Ah, okay, yes. Not idiotic. Right, periodic.
Yeah,
Go ahead.
I'm sorry. You talked about that relates to how energy is not conserved while we're expanding, for example. Is it thought maybe that is what dark energy is? Because
dark energy is an example of a failure to conserve. Dark energy is an example of a failure to conserve energy, certainly. Dark energy is a thing that also doesn't, whose energy is also not conserved. That's well understood, in fact.
Yeah. Did I understand correctly? You said while we're expanding, in some sense, we're losing energy, for example, with photon redshift?
Well, so it depends on what kind of stuff we're talking about. So if you're expanding, so it depends on the, what is it, the equation of state parameter for the stuff. So if you're talking about photons, photons lose energy as you expand. If you talk about dust, dust stays the same energy as you expand. And if you're talking about something like dark energy, which has an equation of state parameter of -1, that grows as you expand. So it just depends on what kind of stuff you're talking about, how it interacts with the expansion of the universe.
I see. And one thing about when people talk about expansion of the universe, I think you said something like it's the vectors of space are kind of scaling and expanding, or all of space is expanding or scaling. What is it?
Yeah, so there's something called the scale factor. That's how we describe the size of the universe. The scale factor is a number, and in some sense it tells you, compared to how distances are now, what was the distance between two fixed things 5 billion years ago, or what will the distance between those two fixed things be in 10 billion years? And so it just tells you the ratio of how much it's grown or shrunk relative to what it is now. So for example, if we set the scale factor to now as 1, meaning that, relative to now, everything is a ratio of 1 relative to the distance that it is now. In 10 billion years, the scale factor might be 2, which means that for two things that are sufficiently far away from each other, their distance will double.
I see. And does everything itself, like particles, do they get bigger or smaller?
Nope. It's just the distance between things.
Okay, that makes sense, yeah. Because I was wondering if everything scales, how would you
nothing
ever...
would change.
Yeah, okay. Okay, and then I have one extra thing if you got the time.
Yeah, sure.
I was wondering if, we have the standard model and quantum mechanics, and from my understanding, like everything we discovered in science on larger scale, I come from mechanical engineering, so stress or strain and everything, or maybe some effects from electricity, like the Hall effect or skin effect, I think it's called.
Sure.
Do you think that using the basic quantum fundamental physics that we know, could one derive everything, every behavior on every scale in theory? Like, could you sit down and derive how mechanical structures behave only knowing quantum physics?
I kind of suspect not. And the reason why I say that is because, so let me back this up. Yes, if you're allowed to solve things numerically. So one could imagine, so certainly it's not the case that you can solve these systems like analytically or in like some closed form formula, just using quantum mechanics, just because the system gets far too big. But like if you have a big enough supercomputer, I suppose you could probably just model the quantum system and then with like a whole bunch of different particles together, and then you could get like the material properties of steel, for example. But we don't have the ability to do that now.
I see, I'm sorry. Because wouldn't you say, you said something about numerical calculations. On large scale, everything kind of averages, right? That's
well,
kind
yeah.
of
So you were asking for an exact. I assume you were asking for like an exact calculation, not like kind of a heuristic that lets you derive those.
Like, could you derive the formulas from mechanical engineering, for example?
Yeah, in principle, sure.
It's kind of an average, right?
Sure.
How a material.
Yeah.
So that you think.
I don't think that that's been done, but yeah, in principle, you could.
Yeah, maybe for some things that could ever be feasible, or maybe the only way we could derive some like behaviors. Do you think so?
That I don't know. I don't know if will it ever be feasible. It might be feasible. I don't know how useful it'll be.
Yeah. Okay. So that's it. Thank you.
All right. Thanks for being here, Luke.
Bye-bye.
To answer some more questions. The universe is getting older and expanding. I'm getting older and expanding. Therefore, I am the universe. True. Very true. Very true. That is a thing that happens. It's normal. Totally normal for a man your age. Or a woman your age. I don't have a preference. Well, I mean, I do have a preference for... let me stop talking. Otis, how's it going?
How's it going, Dr. Blitz?
I'm doing all right. Otis, what questions you got for me?
Well, first, man, I'd like to say I've listened to a lot of your lectures, and I appreciate all that, and I'm glad your health scare
Yeah, me too.
Was a non-issue. Was mathematics discovered or invented? And what would be, what would count as proof for you either way?
I take the view that mathematics is invented. I don't know if this is a question that even has, I don't know how you would prove this. It seems correct to me, considering that like the mathematics that I do, I don't think it's out there in the world. I think I'm just like being creative and coming up with new rules for things. So, at least in my experience, I'm not reaching out to something that already exists. I'm just like, playing a game, basically.
The fact that you answered it that way, man, tells me that you're genuine and you're not, hiding behind the lab coat.
Okay. Any other questions?
No, that was pretty much it, man. That was it.
Well, thanks for being here.
Yep.
That was kind of weird. Right? I feel like I was just being judged. Shaham R, how's it going?
I'm alright, how are you?
I'm doing alright. What questions you got for me?
So I have just one tiny question.
Sure.
My university, I'm stuck between choosing two modules. One of them is either QFT or CFT. I don't know if you can maybe tell me the difference between the two. What would be like a good choice?
Well, okay. I can't tell you what's a good choice because it just depends on what you like more. CFT will be much more connected with actual physical stuff. You can, if you choose to do CFT, what that means is that you can do actual experiments in a lab at your university. You can study data collected in a lab at your university. You're working with samples that you can sometimes even see because they're not like, the size of individual particles. The analysis that you can do can be very so CFT is very tabletop friendly, meaning that like the experiments you can do on a tabletop, you can do your theories, do your phenomenology on a desktop computer. It's very tabletop friendly, and it's very closely connected to the real world. Like a lot of CFT people are working on superconductors or topological conductors, things like this, and these are things that will have actual real world effects if they are sufficiently well studied. QFT, on the other hand, is in some sense more fundamental, right? It's figuring out like what's the deal at the bottom of the universe, like what is actually going on down at the small scales. But your experiments are going to be a lot larger scale. They're going to take a lot longer time. You won't be able to do them in your own laboratory at the university. If you want to look at data there, you're going to have to build a particle accelerator, right? The kind of theory stuff that you do is often going to be on a supercomputer. It's a lot bigger scale, and it's in some sense a lot more like it's harder, not harder in like a sense that like, oh, CFT is easy, but it's harder in the sense that it requires more resources to do. So it really just depends on what kind of thing you're interested in. If you want to have a more kind of direct impact on everyday life, then CFT is probably the way that you want to go. If you want to get at like what's truly fundamental, then QFT is probably the way that you want to go.
Just one other question, if that's okay.
Yeah, it's fine.
For both of them, QFT and CFT, what are like some fundamentals to know like beforehand for both of them?
It depends on whether or not it's theory based or experiment based. In both cases, so I mean, at the end of the day, in some sense, in both cases, you're doing quantum field theory. CFT just uses more discrete stuff, whereas QFT uses more continuous stuff. I guess I don't know what you're asking because I also don't know what level you're at. What do you mean like what are some fundamentals to know about them?
Maybe let me rephrase. Are there like some probably texts that you perhaps know, like textbooks to maybe read up on behind?
I mean, Z's Quantum Field Theory in a Nutshell is a pretty good intro text for quantum field theory. I never took any classes on CFT. I didn't go the CFT route, so I don't know any of the texts that are used in that sub-branch.
Oh, okay. No, I think that's all from me. Thank you so much.
Of course. Thanks for being here, and good luck.
Thanks.
Platonists just cringed with horror and anger. Of course they did. Of course they did, because Platonists are cringe and horrible. Who hides behind their lab coat? Well, I don't even wear lab coats. I've never worn a lab coat. Technically, lab coats are designed to be hid behind. I'd rather the nitric acid on my coat, not my arm. That's a good point. That's a fair point. All right, let's bring up Lux Lunek. Lux Lune? Is that your name? Hope I got it right.
Oh, sorry, the stream's a little bit behind.
Well, now you're here. How's it going?
Yeah, pretty good. You?
I'm doing all right. What questions you got for me?
Well, I was wondering if you could help me understand what algebraically special fluid spacetimes with shearing rays are. What does that mean?
Okay, so algebraically special typically, and I assume the context is GR here. Algebraically special typically means, sorry, one sec. It typically means that either the Weyl curvature or the Riemann curvature has a certain sort of like relations. So one kind of way that you could have algebraically special, an algebraically special relation is that like you could have like some particular polynomial in the curvature tensor, or say in the scalar curvature or something like that, that is 0. So there's some relation that some like algebraic relation that the curvature tensor satisfies. Another way to have an algebraically special curvature or an algebraically special spacetime is when the curvature tensor has overlapping eigenvalues. So you can think of the curvature tensor as being a matrix on 6x6, or a 6x6 matrix rather. On alternating forms, and so you can look at the eigenvalues and you can see whether or not there's all of the eigenvalues are different, or maybe they overlap sometimes. That can also give you some degree of algebraic speciality, but it really depends on the context. And what were the other parts of the question?
The algebraically special fluid spacetimes with shearing rays.
Yeah, so fluid spacetimes, I'm assuming that this is what they're talking about. This is just a spacetime that's filled with a perfect fluid, or perhaps a non-perfect fluid, but a fluid nonetheless. A fluid is it's basically just a specific kind of matter that you can plug into a spacetime that essentially obeys what you would call hydrodynamics. So it kind of flows, and there's a specific way of describing the matter content for such a spacetime. It has a nice kind of simple stress energy tensor. And then we're talking about shearing, what was the last word?
Shearing rays.
Shearing rays. Oh, okay, so when we talk about shear, we're talking about like if you have light rays, you can have it that like, if you have beams of light rays, you could have it that like one will like advance more than the other, for example, so that it kind of like you know what the word shearing means. It's where you can have like kind of sliding. And so we often talk about spacetime, we often describe spacetimes as what they do to bundles of light rays. And so in this case, what we're talking about is that the bundles of light rays kind of shear rather than just expanding or twisting or contracting. There's also a shearing phenomenon happening, and that's describable. You can pick up on shearing from like the Ricciardori equation. So to answer your question, this would be a spacetime that has a specific curvature relation. That's what the algebraically special means. It's filled with some kind of fluid, so it has a specific kind of stress energy tensor. And the description of it having shearing rays just means that the behavior of bundles of light rays in the spacetime, they happen to have this property that they're shearing but not expanding and not rotating. So that's what such a spacetime would be.
And by expanding and rotating, you mean like divergence and curl?
Yes. Yeah.
Right. Okay. Cool.
So typically, the word that's used when we're describing light rays. You'll talk about the expansion is the technical term. You can talk about like the expansion of a null congruence. And you can also talk about the, what do we call it? Do we call it the twist? I think is the technical term for when the rays kind of like curl around each other.
Right. What is my professor calls it swirly.
That's fair.
Swirly fields.
Okay, that's fair.
By the way, Weyl tensor, is that the W-E-Y-L?
Yeah. He was German, so the W's are pronounced as V's.
Yeah, I never knew how to pronounce that. I've only seen it written, so.
I mean, like Americans will say Weyl tensor, or Americans will say Weyl tensor a lot. But my PhD supervisor married a German woman, and so he speaks German decently, so he always pronounces the German properly. So I kind of picked that up from him.
I try to pronounce everything as properly as I can, so yeah, Weyl for me. Cool.
Now you know.
Yeah. All right. Well, that was pretty much my only question. Thanks.
Fair enough. Thanks for being here.
Have a good one.
Bro's quizzing me on the Regidori equation. I think I'm pronouncing that right, but that's a hard name. That's spelled in a challenging way. Okay. We have some more questions. If you had to switch to lab work, what would you work on? Oh, I wouldn't. No, I'd probably do some sort of like electronic stuff. I love fiddling with electronics, especially high voltage electronics. Why am I not seeing lives on my feed? I don't know. That's a good question. All right, y'all. I think I'm going to end the live stream. Oh, well, no, we still have some people that are waiting to come up. So let's bring up those guests. I'm just dehydrated and hungry. But it's for you. Thought likes. How's it going?
Hi. I have like 2 questions. I remember earlier you were talking about quantum medicine.
Yep.
So what in my inorganic theories class, we were talking about nanoparticles, specifically quantum dots, and how they're used in medicine. I would just like, is that like similar to what you were talking about, or like not at all? Because I know it's technically nanomedicine or something, but
quantum dots are a real thing. Quantum dots are a real thing. So that would be an example of quantum medicine. It just, whenever anybody says quantum XYZ, like quantum medicine or quantum healing, I get very, very skeptical immediately.
Okay, yeah. Yeah. I have one more question.
Yeah, sure.
Me and my roommate, we've been having this argument on luck. And so, this might not be exactly like your expertise, but I would like your opinion on it. So his thing is that like luck doesn't technically exist because I guess everything happens like infinitely or something, but I didn't really make sense of that, but he's just saying I don't understand it, which because my thing is like I feel like in our reality there's not actually like infinity, so how could like something happen infinite? I don't know. If you know,
so we don't know if the universe is infinitely large or not. Most models kind of assume that it is, unless they explicitly say otherwise. But I don't think either are really relevant to whether or not luck exists. Luck is like a folkloric way to account for rare things happening, right? But rare things happen. That's just the reality of it. Rare things happen exactly as often as you expect them to happen. We just don't have it's just humans generally don't have a good understanding of probability. Unless, you're actually familiar with probability from like a mathematical point of view.
Yeah, I was trying to tell him it like through like limits, but he like telling me that doesn't like exist, but it's like whatever. Thank you though.
Of course.
I appreciate it. Yeah.
All right, well, thanks for being here, Thought. Have a good one.
Peace.
All right, I think I'm going to end the live now. I'm just very hungry and I need a cup of coffee. I've been up since 5:30. So thank you guys so much for being here. If I didn't get to you, I apologize. Try again next week and I'll try to bring you up. Oh, sorry. We do have one super chat from El Jazone with the $25, which is very appreciated. We used Intro to Quantum Field Theory by Peskin and Schroeder in grad school. I'm familiar with that book too. I struggled following the math until I found the 400 plus pages of errata online. Love your content. Yeah, that's rough. That's real rough, huh? So just as a reminder, if you guys want to be able to participate in this part of the live stream, make sure to become a subscriber. If you're a subscriber on or a super fan on TikTok, then you can send messages. If you are a member on either of the YouTube channels, then you can send messages there. If you are a subscriber on Twitch, you can send messages there and you can ask questions, and you can basically guarantee that your question will get answered over text because there's just not as many. So I'm able to answer them. Yeah, you can use Amazon Prime on Twitch to get, if you have Amazon Prime, you can get a free subscription. And so that's a good way to make sure that your questions get answered every week. I do this for 3 hours every week, purely subscriber questions only. And then also I bring up guests. So consider it. Anyway, I'm gonna end the live stream here. Remember, if you want to check out what I do, if you want to figure out new ways to support me, try going to my website. It's just blitz.phd, no .com, just blitz.phd. And I will